The production of Snickers, one of the world's most popular chocolate bars, is a highly automated and meticulously controlled process designed for efficiency, consistency, and large-scale output. With its signature combination of nougat, caramel, peanuts, and milk chocolate, Snickers is produced in state-of-the-art facilities that use cutting-edge food processing technology, ensuring that every bar meets the brand's high-quality standards. From sourcing the finest raw ingredients to packaging and distribution, every step is optimized to deliver the same taste, texture, and satisfaction in every bite. The journey of a Snickers bar begins with the careful selection of raw materials. The main components include sugar, peanuts, milk powder, cocoa mass, cocoa butter, palm oil, glucose syrup, egg whites, and emulsifiers. These ingredients are sourced from carefully vetted suppliers, ensuring compliance with strict food safety and sustainability standards. Mars, the company behind Snickers, prioritizes responsible ingredient sourcing, ensuring that cocoa is ethically obtained through its Cocoa for Generations program, which promotes fair labor practices and sustainable farming methods. Peanuts, another crucial ingredient, are primarily sourced from the United States, where they are grown under controlled conditions to maintain size, flavor, and crunch. Once the ingredients arrive at the manufacturing facility, they undergo a rigorous quality control process. Each batch is tested for moisture content, purity, and potential contaminants. Peanuts, in particular, go through an additional inspection phase, where they are sorted by size and quality. High-speed optical sorting machines remove any defective or discolored peanuts, ensuring that only the best nuts make it into Snickers bars. The first major step in the Snickers production process is creating the nougat base. Nougat provides the chewy texture that forms the foundation of the bar. It is made by combining sugar, corn syrup, and water, which are heated in large industrial cooking vats to create a syrup. This syrup is then aerated using high-powered whipping machines, which incorporate fine air bubbles, giving the nougat its characteristic light and chewy texture. Egg whites or soy protein are added as stabilizers to help maintain consistency. Once aerated, the nougat is spread onto a moving conveyor belt in a continuous sheet, where it is allowed to cool and set. This process is carefully controlled to prevent the nougat from becoming too hard or too soft. Automated guillotine cutters then slice the nougat sheet into uniform rectangular portions, ensuring that each piece is the exact size required for Snickers bars. Next comes the caramel layer. The caramel in Snickers is made from a blend of sugar, glucose syrup, milk, and butter, which is heated in large stainless steel batch cookers. The temperature is carefully monitored to achieve the perfect viscosity, thick enough to hold its shape, but soft enough to provide a smooth, chewy texture. Once cooked to perfection, the caramel is poured in a controlled stream onto the nougat base. The caramel-covered nougat passes through a cooling tunnel, where it sets just enough to be firm, but still pliable. Now it's time to add the peanuts. Before being incorporated into the bars, the peanuts are roasted in industrial ovens to enhance their flavor and crunch. After roasting, they are cooled and evenly distributed over the caramel layer using precision peanut dispensers. These machines ensure that each bar receives the right amount of peanuts, maintaining uniformity across all Snickers bars. Once the peanuts are in place, the layered nougat, caramel, and peanut sheet moves to the cutting stage. High-speed rotary blades slice the continuous sheet into individual bar-sized portions. Each cut must be precise, ensuring that the caramel and nougat layers remain intact while maintaining a consistent size. The next critical step is chocolate enrobing. The milk chocolate coating used for Snickers bars is made from a blend of cocoa mass, cocoa butter, sugar, and milk powder. This mixture is refined and conched in large machines that continuously grind the chocolate to achieve a smooth texture. The chocolate is then tempered, a process that involves controlled heating and cooling to stabilize the cocoa butter crystals. Proper tempering ensures a glossy finish and prevents fat bloom, which can cause chocolate to develop a dull appearance. At the enrobing station, the cut bars pass through a waterfall of liquid milk chocolate, fully coating them. Excess chocolate is removed using controlled air jets and vibrating conveyors, ensuring an even layer without excessive buildup. Some factories use a two-stage enrobing process, where a thin base coat of chocolate is applied first to create a stable foundation before the final thicker chocolate layer is added. After enrobing, the bars enter a multi-zone cooling tunnel. This tunnel gradually lowers the temperature in controlled stages, allowing the chocolate to set properly without developing cracks or dull spots. Once fully cooled, the Snickers bars emerge with a perfectly solidified chocolate coating, ready for quality inspection. Quality control is a critical component of Snickers production. Each bar undergoes a series of automated inspections to ensure that it meets strict specifications. High-speed vision inspection systems equipped with high-resolution cameras scan each bar for defects such as uneven coating, improper size, or misshapen layers. Any bars that do not meet the required standards are automatically rejected and sent for reprocessing. Additional quality checks include weight verification, moisture content analysis, and sensory testing conducted by trained specialists. Once the bars have passed inspection, they move to the packaging stage. Snickers bars are individually wrapped in plastic film using high-speed horizontal flow wrapping machines. These machines use heat sealing technology to create airtight packaging that preserves freshness and prevents contamination. The wrapped bars are then grouped into multi-packs and packed into branded cartons using automated case packers. The final step in the process is palletization and distribution. Automated systems stack the packaged cartons onto pallets in precise formations, optimizing space for transport. These pallets are then shrink-wrapped for stability and loaded onto temperature-controlled trucks for distribution to retailers worldwide. Snickers bars are shipped to over 70 countries, requiring an advanced logistics network to ensure that they arrive fresh and in perfect condition. Throughout the entire production process, Mars maintains stringent food safety and sustainability practices. Each batch undergoes extensive laboratory testing, including microbiological screening, allergen testing, and texture verification. The company also invests in sustainable ingredient sourcing, reducing its environmental footprint through energy-efficient manufacturing processes and eco-friendly packaging solutions. Different Snickers manufacturing facilities may employ slight variations in processing techniques based on regional ingredient availability and consumer preferences. For example, some regions may use alternative chocolate blends with varying cocoa content, while others may modify the nougat or caramel consistency based on market demands. Additionally, special edition Snickers bars, such as Snickers almond or Snickers peanut butter, require modifications in ingredient formulation and production methods. As consumer preferences evolve, Mars continues to innovate while maintaining the classic Snickers taste and texture. Advancements in automation, AI-driven quality control, and sustainable manufacturing practices are shaping the future of Snickers production. Despite these innovations, the fundamental principles of precision, consistency, and quality remain unchanged, ensuring that every Snickers bar delivers the same delicious combination of chewy nougat, gooey caramel, crunchy peanuts, and smooth milk chocolate that has made it a favorite among chocolate lovers worldwide. The production of Tony's Chocolonely chocolate bars is a carefully designed process that emphasizes ethical sourcing, sustainability, and high-quality chocolate-making techniques. Unlike traditional chocolate brands, Tony's Chocolonely is dedicated to creating a slave-free chocolate industry, ensuring that every step in the supply chain is transparent and fair. From sourcing cocoa beans from cooperatives in West Africa to molding and packaging the final bars, the production process is a seamless blend of traditional craftsmanship and modern automation. The journey of a Tony's Chocolonely bar begins with cocoa sourcing. The company partners with cooperatives in Ghana and Côte d'Ivoire, regions that are known for cocoa production, but also face significant challenges related to child labour and unfair wages. Tony's Chocolonely implements direct trade practices, paying a premium for cocoa and providing additional support to farmers through training programs and financial resources. This ensures that the beans are ethically sourced while maintaining a high standard of quality. Once harvested, the cocoa beans go through a meticulous post-harvest process. Farmers ferment the beans for several days, a crucial step that develops the deep, complex flavors needed for premium chocolate. After fermentation, the beans are spread out under the sun to dry, reducing moisture content and preventing mold growth. When dried to the appropriate level, the beans are packed into jute sacks and shipped to Tony's Chocolonely's processing facilities. Upon arrival at the factory, the beans undergo rigorous quality control checks. Samples from each shipment are tested for moisture levels, flavor consistency, and potential contaminants. Beans that pass inspection are stored in climate-controlled silos to maintain freshness before entering the production line. The first step in the chocolate making process is roasting. Large industrial roasting machines heat the beans at precise temperatures, usually between 120 to 150 degrees Celsius, 248 to 302 degrees Fahrenheit. This process enhances the natural chocolate flavors and eliminates unwanted bitterness. The roasting time and temperature depend on the type of chocolate being produced. Dark chocolate requires a slightly longer roasting process than milk chocolate to develop its rich, bold flavors. Once roasted, the beans enter the winnowing process. A specialized machine cracks open the roasted beans and removes the outer husks, leaving behind the valuable cocoa nibs. These nibs contain both cocoa solids and cocoa butter, the essential components of chocolate. The nibs are then ground into a thick, smooth paste known as chocolate liquor. This process, carried out by industrial grinders, reduces the particle size of the nibs, creating a velvety consistency. At this stage, different chocolate variations begin to take shape. For Tony's Chocolonely's milk chocolate bars, the chocolate liquor is combined with sugar, milk powder, and additional cocoa butter to create a creamy texture. For dark chocolate, higher cocoa percentages are used with less sugar and no milk. The next step in the process is refining. The chocolate mixture is passed through heavy-duty steel rollers that grind the ingredients into ultra-fine particles. This step is crucial for achieving the smooth texture that defines high-quality chocolate. The finer the particles, the better the melt-in-your-mouth experience. Following refining, the chocolate undergoes conching, a process that enhances both texture and flavor. Large conching machines continuously mix and aerate the chocolate for several hours, allowing any residual acidity to evaporate while intensifying the chocolate's richness. The conching time varies depending on the desired flavor profile. Longer conching results in a smoother, more developed taste. After conching, the chocolate is tempered, a precise heating and cooling process that stabilizes the cocoa butter crystals. Proper tempering ensures that Tony's Chocolonely bars have a glossy finish, a satisfying snap when broken, and a long shelf life without developing fat bloom, the white streaks that can appear on improperly tempered chocolate. Once tempered, the liquid chocolate is ready for molding. Unlike most chocolate bars, Tony's Chocolonely bars are intentionally molded in an uneven pattern, symbolizing the unequal distribution of wealth in the chocolate industry. Automated machines pour precise amounts of chocolate into these custom-designed molds, which are then gently vibrated to remove air bubbles and ensure even distribution. The molds are then transferred to a cooling tunnel, where the chocolate gradually solidifies under controlled temperatures. This process prevents the bars from developing surface defects and ensures that they retain their perfect shape. Once the chocolate has fully set, the bars are ejected from the molds and sent to the quality control station. High-speed vision inspection systems scan each bar for defects, such as air bubbles, improper molding, or uneven texture. Any bars that do not meet the required standards are removed from the production line and either reprocessed or discarded. After passing quality checks, the bars move to the packaging stage. Tony's Chocolonely uses brightly coloured, easily recognisable wrappers, each featuring bold typography and branding. The packaging process is fully automated, with high-speed wrapping machines, sealing each bar in foil and paper to protect it from moisture and contamination. The wrapped bars are then packed into cartons using robotic case packers. The final step in the process is palletization and distribution. Automated robotic systems stack the packaged bars onto pallets in a precise arrangement, optimizing space for transport. One of the most famous chocolate bars in the world is made at an unimaginable scale, with millions of KitKats rolling off the production line every single day. But how does a factory create the perfect balance of crispy wafer and smooth chocolate with such precision? Today, we'll take you inside the high-tech process of KitKat production, from mixing all the way to packaging. Get ready to uncover the incredible manufacturing behind one of the world's most beloved treats. The process begins with the careful selection and sourcing of raw ingredients. The primary components of KitKat bars include wheat flour, sugar, cocoa mass, cocoa butter, milk powder, vegetable oils, and emulsifiers. Nestlé, the brand behind KitKat, sources these ingredients from various regions worldwide, ensuring sustainability and adherence to strict quality standards. The cocoa used in KitKat is primarily sourced from the Nestlé Cocoa Plan, which promotes sustainable farming practices and fair trade. Once the raw materials arrive at the production facility, they undergo a series of inspections and tests to verify purity, consistency, and compliance with food safety regulations. This includes spectroscopic analysis for contaminants, moisture content testing, and sensory evaluations conducted by trained professionals. Once approved, the ingredients are stored in temperature-controlled silos and dispensing systems. The flour is kept in airtight storage to prevent contamination, while cocoa and milk powder are maintained under controlled humidity conditions to prevent clumping. Automated feeding systems transport these raw materials to the respective processing units, ensuring precise measurement and consistency in formulation. The first major step in KitKat production is wafer baking. The signature light and crispy wafer layers are created through a precise blending of wheat flour, water, sugar, and vegetable oils. Large industrial mixers, equipped with programmable logic controllers, ensure thorough mixing to produce a smooth and homogeneous batter. Once mixed, the batter is transferred via pressurized pumps to high-speed continuous wafer baking ovens. These ovens feature rotating baking plates that evenly distribute the batter across the surface, forming thin sheets of wafer. The baking plates operate at carefully controlled temperatures, typically around 180 to 200 degrees Celsius, ensuring uniform texture and color. The baked wafer sheets emerge golden brown and crisp, ready for the next stage. To enhance the crispness, the wafer sheets pass through a controlled cooling system. Conveyor belts transport the freshly baked wafers through a cooling tunnel, where calibrated fans gradually reduce the temperature to prevent thermal shock. The cooled wafers are then directed to the trimming and cutting station. Automated guillotine cutters trim the edges of the wafers to achieve uniform dimensions, ensuring consistency across all KitKat bars. Once trimmed, the wafers are transported to the layering station. Here, a fine layer of chocolate cream filling made from a precise blend of cocoa, sugar, and milk powder is evenly spread onto the wafers. automated depositor machines ensure the filling is applied uniformly, maintaining the right thickness for optimal texture. The layering process continues with additional wafer sheets stacked on top, creating a multi-layered wafer slab. These slabs are then pressed under controlled pressure to bond the layers together without crushing the delicate structure. After layering, the wafer slabs proceed to the cutting stage. High-speed rotary or ultrasonic blade systems slice the large wafer sheets into precise rectangular portions, forming the individual KitKat fingers. Ultrasonic cutting technology is particularly effective in ensuring clean, precise cuts without generating excess crumbs or damaging the layers. The next crucial step is chocolate enrobing. The enrobing process begins with the preparation of molten milk chocolate, which is produced in large conching machines. These machines continuously grind and blend cocoa mass, cocoa butter, sugar, and milk powder, refining the mixture to achieve a smooth, velvety consistency. The conching process, which can last several hours, helps develop the rich, creamy texture and enhances the flavor profile of the chocolate. Once ready, the molten chocolate is fed into enrobing machines, where KitKat fingers pass through a curtain-like flow of chocolate. These enrobers ensure complete coverage, with excess chocolate removed using controlled air jets and vibrating conveyors. To achieve the signature glossy finish, the enrobed bars pass through a tempering unit, which carefully regulates the chocolate's crystallization process. This involves a precise cycle of heating, cooling, and reheating to stabilize the cocoa butter crystals, preventing bloom and ensuring a smooth, even texture. Following enrobing, the chocolate-covered KitKat bars enter a cooling tunnel. This tunnel, equipped with multi-zoned cooling technology, gradually reduces the temperature in stages to solidify the chocolate coating without causing cracks or condensation. The cooling process is carefully monitored using infrared sensors to maintain consistency. Once the chocolate is fully set, the KitKat bars move to the quality control and inspection stations. Advanced vision inspection systems, equipped with high-resolution cameras, scan each bar for defects, such as uneven coating, improper sizing, or misaligned layers. Bars that do not meet quality standards are automatically rejected by robotic sorting arms and sent for reprocessing. Additional quality checks include weight verification, moisture content analysis, and sensory testing conducted by trained specialists. After passing inspection, the KitKat bars are transported to high-speed wrapping machines. Individual bars are wrapped in foil or plastic film using heat sealing technology, ensuring airtight packaging that preserves freshness. These wrapped bars are then grouped into multi-packs, which are subsequently boxed using robotic case packers. The packaging design is carefully printed with product details, barcodes, and branding elements before final sealing. The packaged KitKat bars are then palletized for distribution. Automated palletizing systems stack the boxes onto pallets in a precise arrangement to optimize space utilization during transportation. These pallets are shrink-wrapped for stability and loaded onto temperature-controlled trucks for delivery to distribution centers worldwide. The logistics process is carefully coordinated to ensure timely delivery, with real-time tracking systems monitoring shipments from factory to retailer. Throughout the entire production process, extensive quality control measures are in place to uphold product integrity. Each batch undergoes rigorous laboratory testing, including microbiological screening, allergen testing, and texture analysis. Data from all processing stages is logged in automated tracking systems, allowing full traceability and compliance with food safety regulations. While the fundamental principles of KitKat production remain consistent across different manufacturing plants, regional variations may exist to cater to local tastes and preferences. For example, KitKat flavors such as matcha green tea, strawberry, and sake are produced in Japan using specialized formulations. Some factories may also incorporate alternative chocolate blends, varying cocoa content to suit market demands. Nestlé continues to innovate and optimize KitKat production through advancements in automation, sustainability initiatives, and ingredient sourcing. Modern factories are increasingly utilizing AI-driven quality control systems, energy-efficient processing equipment, and eco-friendly packaging solutions to reduce environmental impact. With continuous improvements in manufacturing technology, KitKat remains a global favorite, offering consumers a consistently delightful chocolate experience in every bite. Mars bars, one of the most iconic chocolate confections in the world, are produced in highly sophisticated manufacturing facilities designed to ensure consistency, efficiency, and quality at every step of the process. The production of Mars bars involves multiple intricate stages, from sourcing and processing raw ingredients to forming, enrobing, cooling, and packaging the final product. Each step is meticulously controlled using advanced automation technology and stringent quality control measures to ensure the signature caramel, nougat, and chocolate combination is perfectly replicated in every bar. The process begins with the careful selection of raw ingredients. The main components of a Mars bar include sugar, cocoa mass, cocoa butter, skimmed milk powder, whey powder, palm fat, glucose syrup, lactose, milk fat, and egg whites. These ingredients are sourced from trusted suppliers and undergo rigorous quality assurance checks upon arrival at the factory. Sugar, which plays a crucial role in both the nougat and caramel layers, is stored in large silos, where it is kept dry and free from contamination. Cocoa products, including cocoa mass and cocoa butter, are stored in climate-controlled environments to prevent degradation. Dairy ingredients, such as skimmed milk powder and whey powder, are tested for purity and consistency before use. Once the raw ingredients are approved, the first major stage in Mars bar production is the creation of the nougat layer. Nougat is a key structural component of the bar, providing a soft, chewy texture that contrasts with the caramel and chocolate. The nougat making process begins in large industrial mixing tanks, where a combination of sugar, glucose syrup, and water is heated to create a syrup. This syrup is then aerated using a whipping system, which incorporates fine air bubbles to achieve the desired light and fluffy texture. During this stage, egg whites or hydrolyzed soy protein are added as stabilizers to maintain the nougat's consistency. Once the nougat mixture reaches the proper texture, it is transferred onto a continuous conveyor belt, where it is spread into an even layer. This belt passes through a cooling tunnel to allow the nougat to set before it reaches the next stage of the process. The cooled nougat layer is then precisely cut into rectangular strips using high-speed guillotine cutters. These strips will form the base of each Mars bar. The next step in the process is the caramel layer. The caramel used in Mars bars is created through a controlled cooking process that involves heating sugar, glucose syrup, and milk ingredients to high temperatures. This process requires careful monitoring to achieve the perfect balance of sweetness and viscosity. Industrial batch cookers equipped with automated temperature controls ensure that the caramel reaches the ideal consistency before it is deposited onto the nougat base. The caramel is applied as a continuous sheet over the nougat layer, ensuring even distribution and uniform thickness. Once the caramel is applied, the combined nougat and caramel layers proceed through a controlled cooling tunnel, where the temperature is gradually reduced to allow the caramel to set without becoming too hard or sticky. This ensures that the layers remain cohesive and easy to cut in the next stage of production. After cooling, the layered nougat and caramel sheets are fed into an automated cutting system, which uses precision blades to slice them into individual bar-sized portions. These freshly cut bars are then transported via conveyor belts to the enrobing station, where they receive their final chocolate coating. The enrobing process is a critical step in Mars bar production, as it gives the bars their signature smooth milk chocolate exterior. The chocolate coating is made from a blend of cocoa mass, cocoa butter, sugar, and milk powder, which is carefully tempered to achieve the perfect texture and glossy finish. The tempering process involves heating and cooling the chocolate in a controlled manner to ensure the cocoa butter crystals form a stable structure, preventing fat bloom and ensuring a smooth mouthfeel. At the enrobing station, the cut nougat and caramel bars pass through a curtain-like waterfall of molten chocolate, which fully coats them. Excess chocolate is removed using controlled air jets and vibrating conveyors to ensure an even layer without excessive buildup. Some factories use a two-stage enrobing process, where an initial thin layer of chocolate is applied as a base coat before the final, thicker chocolate layer is added. After enrobing, the chocolate-covered bars enter a multi-zone cooling tunnel, which gradually reduces their temperature in controlled stages. This cooling process allows the chocolate to set properly without developing cracks or a dull surface. The bars emerge from the cooling tunnel with a perfectly set chocolate shell, ready for the final stages of quality control and packaging. Quality control is a fundamental part of Mars bar production, ensuring that only bars meeting strict standards reach consumers. Automated vision inspection systems equipped with high-resolution cameras scan each bar for defects such as uneven coating, misshapen forms, or inconsistencies in size. Bars that do not meet the required specifications are automatically rejected and sent for reprocessing. Additional quality control measures include weight checks using precision weighing systems, texture analysis, and sensory evaluations conducted by trained specialists. Once the bars pass quality inspection, they proceed to the packaging area, where high-speed wrapping machines individually wrap each bar in foil or plastic film. These machines use heat sealing technology to create airtight packaging that preserves freshness and prevents contamination. The wrapped bars are then grouped into multi-packs and placed into branded cartons, which are sealed and labeled using automated case packing systems. The final step in the process is palletization and distribution. Automated palletizing systems stack the packaged bars onto pallets in a precise arrangement to optimize space utilization during transportation. The pallets are shrink-wrapped for stability and loaded onto temperature-controlled trucks for distribution to retail stores and supermarkets worldwide. The entire logistics process is carefully coordinated to ensure timely delivery while maintaining the product's freshness and quality. Throughout the entire manufacturing process, Mars maintains stringent quality control and food safety standards. Each production batch undergoes extensive laboratory testing, including microbial analysis, allergen testing, and moisture content verification. The company also invests in sustainable sourcing initiatives, ensuring that key ingredients such as cocoa and palm oil are responsibly sourced to minimize environmental impact. Different Mars manufacturing facilities may incorporate slight variations in processing techniques based on regional ingredient availability, consumer preferences, or proprietary formulations. Some facilities may use alternative chocolate blends with varying cocoa content to cater to specific markets, while others may modify the nougat formulation for textural differences. Additionally, Mars continuously invests in research and development to improve efficiency, reduce energy consumption, and enhance sustainability in its production processes. With advancements in automation, AI-driven quality control systems, and eco-friendly packaging innovations, the production of Mars bars continues to evolve while maintaining the signature taste and texture that consumers have loved for generations. Twix, one of the world's most beloved chocolate bars, is manufactured using a highly sophisticated and automated process that ensures each bar maintains its signature combination of crunchy biscuit, smooth caramel, and creamy milk chocolate coating. The production of Twix bars occurs in state-of-the-art factories that utilize precision engineering, cutting-edge food processing technology, and rigorous quality control protocols. From the sourcing of raw ingredients to packaging and distribution, every step is carefully orchestrated to guarantee consistency, efficiency, and superior taste. The process begins with the selection and procurement of high-quality raw materials. The key ingredients in Twix bars include wheat flour, sugar, palm oil, cocoa butter, skimmed milk powder, cocoa mass, lactose, whey powder, salt, and emulsifiers. These ingredients are sourced from carefully vetted suppliers who must meet strict food safety and sustainability requirements. For instance, the cocoa used in Twix bars is sourced through Mars' Cocoa for Generations initiative, ensuring ethical sourcing and environmental responsibility. Similarly, the palm oil used in the biscuits and caramel is certified sustainable to reduce environmental impact. Upon arrival at the manufacturing facility, the raw ingredients undergo thorough quality checks before entering the production process. These checks include spectroscopic analysis to detect contaminants, moisture content analysis to ensure freshness, and sensory evaluations to verify taste and aroma. Ingredients that meet the necessary standards are then stored in temperature-controlled silos and storage units to maintain their quality. The first step in the actual production process is the creation of the biscuit base. Twix bars are distinguished by their crunchy, shortbread-like biscuit layer, which requires precise preparation and baking. The process begins in large industrial mixers, where wheat flour, sugar, palm oil, and leavening agents are combined to form a dough. The mixing process is carefully timed to ensure the dough reaches the ideal consistency, firm enough to hold its shape during baking, yet tender enough to create the signature crisp texture. Once the dough is fully mixed, it is transferred to an automated sheeting system. This system rolls the dough into a uniform sheet of the exact thickness required for Twix bars. The sheeted dough then moves to a rotary cutting machine, which stamps out individual biscuit fingers. Each biscuit is precisely cut to ensure uniform size and shape, allowing for seamless assembly in later stages. The cut dough pieces are placed onto conveyor belts and transported into a large industrial baking oven. These ovens operate using a continuous baking system, where the biscuit fingers travel through different heat zones that gradually bake them to perfection. The baking temperature is carefully controlled, typically ranging between 180 to 200 degrees Celsius, 356 to 392 degrees Fahrenheit, ensuring that each biscuit is evenly baked to a golden brown. Advanced infrared sensors monitor the biscuits throughout the baking process, ensuring uniformity in color, texture, and moisture content. Once fully baked, the biscuits pass through a cooling tunnel that gradually reduces their temperature, preventing cracking or breakage. Next, the caramel layer is prepared. The caramel used in Twix bars is made from a precise blend of sugar, glucose syrup, milk, and butter. This mixture is heated in large stainless steel batch cookers, where it undergoes controlled caramelization. The temperature and cooking time are crucial in achieving the perfect consistency, thick enough to stay in place on the biscuit, but soft enough to deliver a smooth, chewy texture. Once the caramel reaches the desired consistency, it is transferred to a continuous depositor system. This machine evenly dispenses a uniform layer of caramel onto each biscuit. The caramel application must be carefully controlled to ensure consistency in thickness across all bars. Any inconsistencies could lead to difficulties in chocolate enrobing or affect the final texture. With the caramel applied, the bars move along the conveyor belt to a cooling station, where they pass through a controlled cooling tunnel. This tunnel gradually reduces the temperature of the caramel, allowing it to set properly while maintaining its soft, chewy texture. After cooling, the caramel-coated biscuits are ready for the enrobing process, where they will be covered in rich milk chocolate. The enrobing process is one of the most critical steps in Twix production. The milk chocolate coating is prepared in large conching machines, which continuously grind and refine cocoa mass, cocoa butter, sugar, and milk powder. This process enhances the texture and flavor of the chocolate, ensuring a smooth, creamy consistency. The chocolate is then tempered, a controlled heating and cooling process that stabilizes the cocoa butter crystals. Proper tempering is essential to achieving the signature glossy finish and preventing fat bloom, white streaks that can appear on improperly tempered chocolate. At the enrobing station, the caramel-topped biscuits pass through a continuous chocolate waterfall. This ensures that each bar is fully coated in an even layer of chocolate. Any excess chocolate is removed using controlled air jets and vibrating conveyors, which help distribute the chocolate evenly without excessive buildup. Some factories employ a two-stage enrobing process, where a thin base coat of chocolate is applied first to ensure better adhesion before the final, thicker chocolate layer is added. Once the bars are coated, they enter a multi-zone cooling tunnel. This tunnel is divided into different temperature zones that gradually reduce the temperature, allowing the chocolate to set perfectly without cracking or becoming dull. The bars emerge from the cooling tunnel with a firm, glossy chocolate coating, ready for the next stage of production. Quality control is a top priority at every stage of Twix production. After cooling, the bars pass through a series of automated inspection systems. High-speed vision cameras scan each bar for inconsistencies in chocolate coating, caramel distribution, and overall shape. Any bars that do not meet specifications are automatically rejected and sent for reprocessing. In addition to visual inspections, quality control teams conduct random weight checks, moisture analysis, and sensory evaluations to ensure that each batch meets Mars's stringent quality standards. Once the bars have passed inspection, they move to the packaging stage. Twix bars are individually wrapped using high-speed horizontal flow wrapping machines. These machines use heat-sealing technology to create airtight packaging that preserves freshness and prevents contamination. The wrapped bars are then grouped into multi-packs, which are sealed in branded cartons using automated case packing systems. After packaging, the final step in the process is palletization and distribution. Robotic palletizing systems stack the packaged bars onto pallets in precise arrangements, optimizing space for transport. The pallets are then shrink-wrapped for stability and loaded onto temperature-controlled trucks for distribution to retailers worldwide. Mars utilizes an advanced logistics network to ensure efficient delivery while maintaining product freshness. Throughout the entire production process, Mars adheres to strict food safety and sustainability standards. Each batch undergoes rigorous laboratory testing, including microbiological analysis, allergen testing, and texture verification. The company also invests in eco-friendly initiatives, such as reducing energy consumption in manufacturing and using recyclable packaging materials. Different Mars factories may employ slight variations in processing techniques based on regional ingredient availability and consumer preferences. For example, some regions may use alternative chocolate formulations with varying cocoa content, while others may adjust the caramel consistency based on market preferences. Additionally, limited edition Twix flavors, such as Twix white chocolate and Twix peanut butter, require modifications in ingredient formulation and processing techniques. As consumer demand for innovative flavors and healthier options grows, Mars continues to invest in research and development to improve Twix production. Recent advancements in AI-driven quality control, robotic automation, and sustainable ingredient sourcing are shaping the future of Twix manufacturing. Despite these innovations, the core principles of precision, consistency, and quality remain unchanged, ensuring that every Twix bar delivers the signature, crunchy, chewy, and chocolatey experience that consumers love. The making of a Hershey's chocolate bar is a complex, highly automated process that combines tradition with cutting-edge technology. From sourcing high-quality cocoa beans to wrapping the final product, every step is optimized for efficiency, consistency, and taste. The journey of a Hershey's bar begins with the careful selection of raw ingredients sourced from around the world. Cocoa, sugar, milk, and other ingredients are carefully tested to ensure they meet the company's high standards before they are transformed into the iconic chocolate bars that have been loved for generations. At the heart of every Hershey's chocolate bar is cocoa. The company sources its cocoa beans primarily from Ghana, Côte d'Ivoire, and Ecuador, regions known for producing high-quality beans with robust flavor profiles. Cocoa farmers in these areas harvest the ripe pods, extract the cocoa beans, and allow them to ferment for several days to develop their characteristic chocolatey taste. Once dried, the beans are shipped to Hershey's production facilities, where they undergo rigorous quality checks. Each shipment is tested for moisture content, flavor consistency, and the absence of contaminants. Only the highest quality beans make it through this stringent selection process. Once approved, the cocoa beans are sent to the roasting stage. Large industrial roasters expose the beans to carefully controlled heat, typically between 120 to 150 degrees Celsius, 248 to 302 degrees Fahrenheit, depending on the desired flavor profile. The roasting process is essential for developing the deep, complex flavors of chocolate. Different roasting profiles are used depending on whether the beans will be used for milk chocolate, dark chocolate, or other specialty products. After roasting, the cocoa beans enter the winnowing process. Specialized machinery cracks the roasted beans and removes the outer husks, leaving behind the valuable cocoa nibs. These nibs contain both the cocoa solids and cocoa butter needed for chocolate production. The nibs are then ground into a thick, dark paste known as chocolate liquor, which contains no alcohol despite its name. This chocolate liquor is the base for all Hershey's chocolate products. For Hershey's classic milk chocolate bars, chocolate liquor is combined with sugar, milk, and cocoa butter. The milk used in Hershey's chocolate is a key ingredient that gives it its distinctive taste. Unlike many European chocolates that use powdered or condensed milk, Hershey's uses fresh milk sourced from dairy farms in Pennsylvania and surrounding states. The milk is pasteurized and condensed before being blended with sugar to create a sweet, creamy base. The next stage in the process is refining. The chocolate mixture is run through a series of steel rollers that grind the particles to an ultra-fine consistency. This refining process is crucial for creating a smooth, melt-in-your-mouth texture. The finer the particles, the smoother the final chocolate will be. Once refined, the chocolate undergoes conching, a critical process that enhances flavor and texture. Conching machines, which resemble large industrial mixers, continuously stir the chocolate at controlled temperatures for several hours. This process aerates the chocolate, allowing unwanted acidic compounds to evaporate while enhancing its creamy mouthfeel. Hershey's uses a proprietary conching method that contributes to its signature flavor, which has a slightly tangy undertone due to controlled acidity in the milk. After conching, the chocolate moves to the tempering stage. Tempering is the process of heating and cooling chocolate in a precise manner to stabilize the cocoa butter crystals. Proper tempering ensures that Hershey's bars have a glossy finish, a firm snap, and a long shelf life. If the chocolate were not tempered correctly, it could develop fat bloom, a whitish streaking effect caused by unstable cocoa butter. Now, the tempered chocolate is ready for molding. Automated machines pour precise amounts of liquid chocolate into bar-shaped molds, which are then vibrated to remove air bubbles and ensure even distribution. The molds travel along a conveyor system into a cooling tunnel, where the chocolate solidifies into its final shape. Once cooled, the bars are ejected from their molds and transported via conveyor belts to the packaging area. Here, high-speed wrapping machines encase each bar in foil and branded paper sleeves, protecting the chocolate from moisture and light while ensuring a fresh, appealing presentation. Throughout the entire process, strict quality control measures are in place. High-resolution vision inspection systems scan each bar for defects, such as air bubbles, improper molding, or size inconsistencies. Bars that do not meet specifications are automatically rejected and sent for reprocessing. Additionally, random sensory evaluations are conducted by trained taste testers to ensure that the flavor, texture, and overall quality remain consistent. Once packaged, the final step is palletization and distribution. Automated robotic arms stack the packaged bars onto pallets, which are then shrink-wrapped for stability. These pallets are loaded onto temperature-controlled trucks and shipped to retailers worldwide. Hershey's operates an advanced logistics network that ensures timely delivery while maintaining product freshness. The entire manufacturing process is designed for efficiency, consistency, and sustainability. Hershey's continues to invest in eco-friendly initiatives, such as reducing water and energy consumption in production, using ethically sourced cocoa, and optimizing packaging materials to minimize waste. Different Hershey's factories may employ slight variations in processing techniques based on regional preferences and ingredient availability. Additionally, specialty products like Hershey's cookies and cream bars or Hershey's dark chocolate require modifications in ingredient formulation and processing times. As the chocolate industry continues to evolve, Hershey's remains at the forefront of innovation, combining tradition with advanced manufacturing techniques to produce its iconic chocolate bars. Through precision engineering, strict quality control, and a commitment to excellence, Hershey's ensures that every bar delivers the same beloved taste that generations have enjoyed. Today's journey towards KFC tenders begins in the serene environment of this amazing poultry house, which is located in the United States. Being KFC's biggest supplier, these farms are not just places where chickens are raised. They are carefully designed spaces dedicated to the well-being of the birds. Automatic dispensers play a key role in maintaining the chicken's health. Fresh, clean water is always available thanks to these dispensers. In spacious barns, chickens are given room to roam freely, unlike the cramped conditions found in some other farming setups. This freedom is crucial because a stress-free environment helps the chickens grow healthy and robust. Once the chickens are deemed chicken collection ready, these modern collecting machines arrive at the farms. These machines are somewhat like large vacuum systems, but with a gentle touch. Instead of sucking up the chickens roughly, they handle them with great care. Once the chickens are collected, they are placed into clean, secure crates. These crates are specifically designed to ensure the safety and comfort. This helps reduce stress and keeps them calm throughout the trip. Upon arrival at the processing plant, the chickens are unloaded with the same care and attention they received throughout their journey. The unloading process is handled by experienced workers who use a bunch of conveyor belts and understand the importance of gentle handling. The focus remains on maintaining their health and safety, which is crucial for producing high-quality products. The processing plant is a marvel of modern technology designed to handle large volumes of chickens while ensuring efficiency and precision. As the chickens travel along the conveyor belt, they pass through a stunning machine. This machine is designed to render the chickens unconscious in a way that is both quick and painless. One of the most important steps in the processing plant is ensuring the chickens are treated humanely. This commitment to humane treatment reflects the industry's focus on animal welfare. The chickens move to the feather removal stage. This is where a specialized machine removes all the feathers from the chickens. One of the first steps involves separating the chicken feet from the rest of the body. After the feet are removed, the chickens move on to the next stage, where their internal sections are cleaned out. Once the internal cleaning is complete, the chickens are thoroughly washed. The washing process is held in a pool of water that also uses high-pressure water jets to remove any remaining blood or impurities. With the chickens dried, the next stage involves cutting them into various parts, keeping the breast pieces for KFC tenders processing, as they are known for their juicy tenderness. The rest of the chicken will also be cut into pieces and collected for further selling purposes. I almost forgot, but the machines, before making cuts to the breast pieces, use abrasive roller pins to conveniently remove the skin from the breast piece, so you never have to compromise on taste and quality. Specialized machines are used to make precise cuts, separating the breast from the rest of the chicken. These machines are designed to handle the chicken gently while ensuring that each cut is clean and accurate. The breast pieces are cut from the bony parts of the chicken, which are handled separately. Once the chicken breasts are separated from the rest of the chicken, they are carefully collected. Now, the breast pieces are being placed into drum rollers. This part of the process is designed to make the chicken breasts even juicier. The drum rollers gently tumble the chicken pieces, allowing them to lock in moisture and enhance the overall tenderness of the chicken. After the drum rollers, the chicken pieces move to the sorting stage. Here, they are manually placed on running belts, more like sieves. These sieves allow experts to inspect each piece carefully to ensure that the chicken is safe to eat. The pieces are then sprayed with a solution responsible for removing any harmful bacteria from the surface. The spray helps to reduce the risk of contamination and ensures that the chicken is clean and ready. We are really working hard to entertain you guys. If you think we deserve your like, please hit that like button. Once the chicken pieces are thoroughly cleaned, they are coated with flour to create a delicious texture for the chicken and help in forming a crispy coating when fried. Importantly, no artificial ingredients are used in this flour coating. The flour-covered pieces are then transported on shaker or vibrating belts, which ensure that the coating is applied evenly and that the pieces are aligned in a uniform shape. This partial frying locks in the tenderness and juiciness of the chicken while giving it a golden brown color and a crisp texture on the outside. Cheese cubes are a popular snack and ingredient in many dishes, prized for their gooey, melty centers and crispy coatings when fried. The battered cheese cubes are passed through a bed of breadcrumbs in the automatic machine. These machines not only increase efficiency, but also ensure consistency and quality in the final product. By automating the process, manufacturers can produce large quantities of cheese cubes with perfect coatings every time. From mixing ingredients to packaging the final product, every step is designed to create patties that are not only delicious, but also made with remarkable efficiency. carrying the capacity of 1,500 liters at a time, they can literally cope with the bigger projects, like more than hundreds of thousands of patties every day. Check out that smooth process to package the burger patties to avoid inconvenience. Enjoying that burger crunch or dreaming right now. Anyways, in both cases, you need to complete that fast food party with chicken nuggets. Even if you don't like those crispy and juicy chicken nuggets, you've got to watch this video that may trigger some taste buds in you. For that appealing golden brown appearance, they fry these nuggets for around 70%, so they will be almost ready when you place your order in restaurants. Automation like these becomes even more fascinating when they give a touch of love and care. Here are two sorts of nuggets being made, and if you ask me, both are something delicious enough to die for. I'm kind of a huge foodie. Freshly harvested potatoes arrive at the factory, where the chosen potatoes are gently loaded onto a conveyor belt. This belt carries them smoothly into the heart of the washing area, where a steady stream of water showers over them. This stage is important in maintaining the potatoes' hygiene and ensuring they are free from any contaminants that could compromise their quality. After the initial rinse, the potatoes enter a brushing and scrubbing phase. Here, soft brushes mounted on rotating cylinders gently massage the potato skins. Once thoroughly washed, the clean potatoes proceed to a drying stage. That's a step which is typically 2 in 1, meaning they keep on drying naturally while moving ahead towards further processing, which will be peeling. Obviously, what else could it be? Potatoes enter the automatic peeling station, where abrasive rollers gently remove their skins so they can be moved to these big choppers, which literally cut the potatoes into uniform chunks. This factory is literally multitasking because it doesn't only prepare potatoes for silky smooth mashed potatoes, but also gets the various forms of potatoes ready for dozens of cuisines. For example, here the special cutters have cut the potatoes into wedge shapes, so potato wedges aren't a hassle. While some of the peeled potatoes are sent for further examination, a bunch of experts pass the good quality potatoes to be cut into halves and packed immediately. Yes, because we can't wait more to show you guys the satisfying process of making mashed potatoes in bulk. To prepare the creamiest and most flavorful mashed potatoes, these experts are boiling the potatoes right on the spot. Meanwhile, in many households like mine, where spare time is literally an issue, already boiled potatoes, boiled a day or two before, are used to make mashed potatoes really quick. But these buddies know never to compromise their crowning taste. When the potatoes are perfectly boiled, the unnecessary water is drained, and the steamy hot potatoes get their Disney oil treatment in a smooth blender. As they are the main character, the blender keeps on rotating, while, bit by bit, butter is added into it to give them a thorough and creamy blend. Talk about creamy. In order to make mashed potatoes creamy and dreamy, they'll pour in a specific amount of milk and mix it all over again. This gives the mashed potatoes a smooth texture, and that perfect consistency makes you crave having more. And there you have it. The superheroes have gone through the ultimate transformation, and the best one, ready to be served as a delicious, creamy side dish or main. It totally depends on your taste. Never underestimate any smaller element, even if it's a small gesture or machine like this nozzle, pouring the equal quantity of mashed potatoes in every batch. It was literally a team effort, but we don't end here. There's a lot more craziness to watch, so stick with us. One of the famous international frozen pizza companies is on a mission to create the most delicious pizza ever. So, starting off right with smooth and fluffy dough, which is balled up and spread out neatly in thousands of pizza pans for quick and partial baking. Meanwhile, the pizza sauce is being prepared and neatly spread over the baked dough by some automatic machines, so they do not really need manual help. You know, cheese could go bad, so before it may ruin the entire pizza party, they check it for its top-notch quality beforehand. If it's good enough, the crushers shred the entire cheese blocks and sprinkle them over thousands of pizzas to give these pizzas a perfect texture. Some more cheese slices are neatly added onto them to finish it off. They pour some other sauces and ingredients so the pizzas are ready to be frozen right away. Finally, the pizzas are covered with a transparent food sheet and packed into boxes to keep them fresh and preserved. These machines won't even demand appreciation, but they do deserve it, right? So hit the like button for the sake of these and many such robotic machines working tirelessly to give you the perfect outcome every time. Just check out how this ordinary looking dough is going to transform into the perfect buns with a single push of a button. Yes, this entire automation you're watching right now on your screens doesn't involve manual help. Once balled up and rested in their dedicated pans, these fluffy dough balls are kept for a couple of minutes until the dough rises again, and the vacuum can blow off extra crumbs to give it a neat finishing look. However, when the buns are perfectly baked, they are all set to get dressed. Hey, if you like our video, please give it a thumbs up and support us for creating more of such content for you guys. As I always say, you're all we have. Look at those nozzles pouring out the delicious jam on each half to give the best mouth-bursting flavors. Let's indulge in the golden sweetness of honey candies, where each bite is a taste of pure honey. Here, the process begins with the blend of pure honey and other required ingredients, transformed by super smart rollers into a thick, delightful mixture. Rolled out consistently and kneaded thoroughly. Just look at that consistency. It's so rich and smooth. This is so beautiful. How these machines continuously knead the candy material without taking a break to make sure it perfectly fits your standards. Now, that little automated machine makes sure that each candy gets the perfect and desired shape and cut. As the candies move through the production line, quality control sensors monitor each piece. These sensors check for consistency in size, shape, and texture. Once the candies have cooled and set, they are transferred to the wrapping machine. This machine wraps the bunch of candies in protective packaging, keeping them fresh and preventing them from sticking together. Each pack holds around 9 candies, loved worldwide for their pure taste and eye-catching packaging. The candies are then packaged into boxes using huge packaging machinery. This step prepares the candies for distribution and makes them ready for shipping. Stop messing with your sweet-tooth nature. Not everything sweet is worth tasting. So grab only your favorite honey-topped biscuits that are rich in taste and super affordable. Do tell me when you find one. Jelly Belly candies are true gummy candies that are crispy from the outside, but a mouthful of liquid flavor bursts into your mouth as soon as you munch them. First, they mix these ingredients together in a big machine until it's just right. Once the mix is ready, the machines pour it into molds to shape the candies. Now it's time for their rest, which is not going to take so long. Once the candies cool down, they're taken out of the molds and spun around in a special machine. This makes sure they're the perfect size, shape, and texture. They make lots of candies this way, so there are tons of flavors to try. With so many different flavors, there's a Jelly Belly for every mood, and you're sure to find one you love. They make sure everyone can enjoy their favorite flavored candy and have a great time eating it. With so many different tastes, from fruity to sweet and everything in between, you'll never get bored. They surely turn snacking into a fun journey where you can discover your new favorite flavor with every bite. When it comes to comparing super smart machines with human hands, robotic machines take the cake. They do everything super fast, perfectly, and with precision. Like right now, these machines are helping to create thousands of baked crusts to be filled with different sweet and savory sauces later by bakeries and restaurants. Loads of fresh meat are brought in and fed into a super fast chopping machine. This machine cuts it all up into equal-sized pieces and packs them neatly into cans. They seal each tin tight with a cover and label using robotic hands in very little time. Creating perfect and smooth dough is a challenging task for human hands. However, for a magical machine, shaping it into equal-sized pieces is no big deal. As soon as the dough is ready and balls are prepared, they undergo a smooth waffle-making machine that rolls them up while baking them in the meantime. This ensures no additional time is wasted, and the result is just hilarious. In today's busy time, sandwiches are considered the perfect meal. Just pair one with a cup of coffee or tea for an easy energy boost. Advanced machinery prepares these sandwiches automatically, taking less time than you can imagine while packing a full energy punch. Different fruit flavors become uniquely delicious when enjoyed in various ways. Transforming the amazing juice and fresh fruit flavors into sweet delights and candies is a breeze for robotic machines. Advanced machinery ensures these flavors are smooth and their textures consistent, making the taste incredibly delicious and enhanced. Robotic machines cut, shape, and create perfectly equal-sized candies in bulk in the blink of an eye. The candies are moved to be wrapped in beautiful, eye-catching wrappers, ready to be enjoyed. Watch this video and you'll see how these machines make the perfect donut-shaped sponge cakes, which later will be topped and dipped into creamy and rich chocolate. Each donut is uniformly crafted and beautifully finished. To enhance the creamy flavor, a drizzle of chocolate syrup is added on top to make every bite a delightful experience. After finishing, they move on to the next process. Here's how sushi goes from a simple idea to the delicious rolls you love. Let's explore the world of sushi, where rice meets seaweed and every roll tells a story. Let's start with the star of the show, rice. First, the workers scoop up high-quality sushi rice and put the stock through sieves to make sure only the best quality grains make it to your plates. Now it's time to get them soaked in water to get the perfectly cooked sushi rice. Here, the rice pots are getting ready, and check out that one-push automation making everything pretty simple. Large machines are going to cook the rice in big batches, so they need to make sure everything gets in place. While the rice is rinsed multiple times until the water runs clear, they add a little bit of vinegar and oil to cook the rice up to the mark. Letting them settle for a moment, the pots are put over the stoves. These machines use precise temperature controls and timings to ensure the rice is cooked perfectly every time. Pretty good if they can check the right moisture and consistency. The rice is steamed and cooked until it's soft and fluffy, just perfect for sushi rolls. Garnishing with a little bit of oil will help to move the rice smoothly. The rice is gently stirred to make sure every grain gets coated with seasoning so that the flavorful rice sticks together just right. The seasoned rice is then cooled to the perfect temperature for rolling. Let's watch the preparation of the rest of the ingredients to make thousands of perfect rolls of sushi. With everything ready, now comes the fun part, assembling the sushi rolls. The machines spread the seasoned rice onto the conveyor belt, while the workers place the meats and veggies on top of the rice as it moves on a conveyor belt. From fresh, crisp vegetables to seaweed and other picked ingredients to enhance the flavors. Everything is all lined up for this step. The precise placement of these ingredients is crucial for ensuring that every sushi roll has a balanced flavor and texture. Thanks to the labor that finally made it possible, allow me to show you these beautiful scenes. Finally, the rice and filling are rolled up to make the delicious sushi rolls. This would all be done with the help of these rolling machines, which will perfectly roll out the assembled sushi sheets. Just look at those enormous sushi rolls. Aren't they mouth-watering? This one was a billion times satisfactory adventure that I'm never going to forget. The workers now cover the sushi rolls with seaweed sheets and feed the sushi rolls into the machine that slices the big rolls into bite-sized pieces. The ready-to-eat rolls are now all set to get covered inside the special packaging, which seals them to keep them fresh. Now let's set off on a tasty journey of the production of your favorite snack, kimbap. Workers carefully add a mix of spicy sauces to the freshly cooked rice. This blend of flavors gives the kimbap its unique kick. The rice is stirred with precision to make sure every grain is coated with that zesty, spicy goodness. After the rice gets its spicy makeover, the machines spread it evenly, and it is then topped with meat or other preferences and sauces to add crunch and color to each kimbap pack. This is exactly how kimbap gets its crowning triangular shape. This shape makes them easy to grab and even easier to enjoy. Each piece is carefully cut to make sure it's just the right size for a perfect bite. The neatly cut kimbap pieces are placed into individual packs. Each pack is sealed tightly to keep the kimbap fresh and flavorful. And that's how your favorite kimbap packs come to your plates. Let's now move on to another beloved snack, crispy fried chicken nuggets. These nuggets are a favorite among people of all ages, and their production process is as fascinating as their taste. First, large quantities of fresh chicken meat are brought into the factory and prepared for processing. The chicken pieces are carefully cut into uniform shapes and sizes by high-speed chopping machines, ensuring each nugget is consistent. Once cut, the chicken pieces are passed through a marination station where they are coated in a blend of herbs, spices, and seasoning. The marination process ensures that every bite is packed with flavor. After marination, the nuggets are passed through a battering station where they are evenly coated in a smooth, flavorful batter. Following this, the nuggets move to the breadcrumb coating stage. This step ensures the nuggets get their signature crispy texture after frying. The coated nuggets are then partially fried. This partial frying process locks in the juiciness of the meat while giving the nuggets a golden brown color and a crispy outer layer. After partial frying, the nuggets are rapidly frozen to preserve their freshness and flavor. They are then packed into airtight bags and prepared for shipping to various restaurants and retail outlets worldwide. Next, let's talk about potatoes. Potatoes are one of the most versatile foods, and their journey from the farm to your plate is nothing short of extraordinary. After being washed, scrubbed, and peeled, the potatoes are sent through slicing machines that cut them into various shapes. Some are turned into classic fries, others into wedges, and some into thin slices for chips. These potato cuts are then rinsed again to remove any excess starch. They are then partially fried in large industrial fryers. This step ensures that when you cook them at home or they are fried at a restaurant, they will achieve that perfect, crispy texture. After frying, the potato pieces are rapidly frozen and packed into bags, ready to be delivered to your favorite fast food outlets or grocery stores. Now, let's dive into the world of frozen burger patties. Large cuts of fresh beef or chicken are brought into the processing plant, where they are ground into a fine texture. Seasoning is added, and the mixture is carefully blended to ensure even distribution of flavors. The mixture is then fed into patty-forming machines that shape the ground meat into perfectly round patties. These patties are then passed through a cooking tunnel, where they are partially cooked to lock in moisture and flavor. After cooking, the patties are rapidly frozen and packed into individual portions. This ensures they remain fresh and ready for cooking whenever you crave a burger. Next, let's explore the production of creamy mashed potatoes. Once the potatoes are washed, peeled, and boiled, they are transferred to large industrial blenders. Bit by bit, butter and milk are added while the blenders mix the potatoes into a creamy, smooth texture. The mixture is carefully monitored to ensure it reaches the perfect consistency. After blending, the mashed potatoes are portioned into containers using precision nozzles. Each batch is sealed to maintain freshness and is then prepared for distribution. These ready-to-eat mashed potatoes can be found in grocery stores or served at your favorite restaurants. Now let's move on to one of the most beloved treats, honey candies. The process begins with blending pure honey with other ingredients, such as sugar and natural flavorings. This mixture is heated until it reaches the perfect consistency. Once the candy mixture is ready, it is poured into molds to give it the desired shape. After cooling, the candies are removed from the molds and pass through quality control sensors. These sensors ensure that each candy meets the required standards in terms of size, shape, and texture. Once approved, the candies are wrapped in protective packaging to maintain their freshness and prevent them from sticking together. They are then packed into boxes and prepared for shipping. Let's not forget about donuts, a treat that brings joy to people worldwide. The donut production process begins with preparing soft, fluffy dough. The dough is mixed, kneaded, and portioned into uniform shapes using specialized machines. These dough pieces are then transferred to donut fryers, where they are fried until they achieve a golden brown color. After frying, the donuts are cooled and pass through a glazing station, where they are coated with a layer of sweet icing or syrup. Some donuts are also filled with cream, jelly, or chocolate using precision nozzles. Finally, they are packed into boxes, ready to be delivered to bakeries, cafes, or grocery stores. Now let's talk about sushi, an art form as much as it is a meal. The process begins with cooking high-quality sushi rice, which is seasoned with vinegar and sugar. The rice is cooled and then spread evenly on sheets of seaweed by automated machines. Fresh ingredients like fish, vegetables, and sauces are carefully placed on the rice. The sheets are rolled into cylindrical shapes using specialized rolling machines. These rolls are then cut into bite-sized pieces using sharp, automated knives. Each sushi roll is inspected for quality and consistency before being packed into airtight containers. This ensures the sushi remains fresh and flavorful when it reaches your plate. Kimbap, a popular Korean dish, follows a similar process. Freshly cooked rice is seasoned with a mix of sauces and spices. The seasoned rice is spread onto sheets of seaweed and topped with a variety of ingredients, including vegetables, meat, and sauces. The sheets are then rolled and cut into triangular shapes, making them easy to eat. Is carefully wrapped in protective packaging and sealed to maintain its freshness. These neatly packed kimbap rolls are then shipped to grocery stores, convenience stores, and restaurants worldwide. In conclusion, whether it's fried chicken, cheese cubes, nuggets, potatoes, mashed potatoes, burgers, donuts, sushi, or kimbap, every product goes through a series of meticulously automated processes. Each step is carefully monitored and executed with precision to ensure quality, consistency, and safety. These automated machines and advanced technologies play a crucial role in delivering your favorite snacks and meals to your plate. From the farm to the factory, and finally to your dining table, every step is a testament to human innovation and the tireless efficiency of modern machinery. Firstly, that beast machine steps into the fields and starts shaking, loosening the peanuts from the roots and turning them inside out. After the plants are dug up, they're left to dry in the sun for a few days. Now the excess moisture is removed from the peanuts, and they are ready to be picked up. Here come those bulky mechanical friends to do this job. Way much easier than it seems. It picks up the dried plants, separates the peanuts from other debris, and collects them in a hopper. From the last decade, China has been the largest producer of peanuts, and this strategic country usually makes a final count of around 20 million tons of peanuts every year. We have arrived at the facility where the entire peanut pile is fed into the cleaning setup. The unwanted stuff, like stones, twigs, and other foreign materials, is removed through pre-screening. This deshelling process is most satisfying when the machines delicately remove the outer shells of peanuts and reveal that beautiful, potential, and healthy nut we all were waiting for. Hang in there for a moment. They need to inspect manually for a quality check before they send the peanuts towards seed coating removing machines. Here, With gentle shaking, a lot of air pressure, and proper programming, that brownish skin is removed from the peanuts. The peanuts are treated with a medium boiling process to lock their texture and flavor and sanitize them by killing off any harmful bacteria or microorganisms by keeping the approximate boiling temperature near 121 stacking Quicks. However, it varies from company to company. As soon as the hopper is filled with the boiled peanuts, they are immediately packed and sealed in cans for distribution. These roasted peanuts are going to transform into something super buttery and delicious. Following a little roasting, the peanuts are cooled down to reach a temperature that is safe for handling and prevents them from becoming too hot or soggy during grinding. Those chosen peanuts take a trip towards this grinder and start revealing the smooth, buttery paste we all crave. It keeps grinding the peanuts until it reaches the desired smoothness, and the magic ingredients that will enhance the flavor keep being added little by little. This whirlwind of crushing and blending turns those nuts into pure deliciousness until it's homogenization. This step is chaos that gives way to harmony. Through higher pressure, the peanut butter gains its final and smooth texture. Witness this final stage where the bottles are getting filled and sealed to secure the fresh peanut butter inside. Automated machines, like filling and cap sealing machines, work tirelessly, ensuring each jar is brimming with creamy goodness. Each jar gets dressed up, ready to impress on the supermarket shelf. Whether spread on toast, topped over ice cream, or simply enjoyed with a spoonful, chocolate peanut butter never fails to delight the senses. Chocolate peanut butter serves the taste buds with its rich, creamy texture and harmonious blend of sweet and nutty flavors. Look at those different patterns those machines are creating to give us that satisfying sight. It's more like a powerhouse of protein and other essentials for muscle repair and growth. It's delicious and satisfies your hunger between meals. Those roasted peanuts are ready for a delicious chocolate coating. This chocolate coating process requires precision to ensure each peanut is evenly coated. After coating, the peanuts are left to cool and harden. Once cooled, they are carefully packaged into food-grade safe containers for distribution and sale. Have you ever tried these? Honestly, I never have. If we talk about those chilled, delightful ice creams, you all know it's pretty popular around the globe. Every day in the United States, people consume around 50 million ice cream pints. That's enough to fill more than 9 Olympic-sized swimming pools. Whether it's a hot summer day or a chilly winter evening, Americans' love for this sweet treat stays strong all year round. And why wouldn't it? Just look at how creamy, rich, and delightful they are. Have you ever tried these Taiwanese crackers? They are pretty familiar and loved by many, from adults to children. In addition to their delicious taste and texture, Taiwanese crackers are also celebrated for their simplicity. Made from basic ingredients, they create a magical burst of flavors inside your mouth. Their straightforward approach allows the natural flavors to shine through, resulting in an authentic and satisfying snacking experience. These snacks come in a range of textures, from crispy and airy to dense and crunchy. In the last few years, there have been several conspiracies about their oil spraying, but I don't think it is a problem. Because if you dig deeper, snacking as a whole would be considered unhealthy. But after much time, a little snacking won't hurt. Do you agree? No doubt at least their production is pretty satisfying to watch. Check out the magical power of these automated systems for juice-filling sectors, where every drop counts, reducing electricity consumption. You will barely see more than a few workers working around because of the efficient automation. Talking about these bulky productions is my love language. I always fall for them. Do you? If it's a yes, we are the same, bro. So cheers to that. I want you to comment down below and let us all know whether you prefer bottled or fresh juices and why that is. Think you had a hard time scooping out the sweet and juicy flesh from the pineapple shell? I ruined 4 large pineapples just to bring out a nice pineapple ring. Didn't waste the rest though. Surprisingly, burger meat patties are low in carbs. A beef patty typically has none unless extras are added. These delicious burger patties are full of energy and nutrients, perfect for fueling your day in the most appealing ways you have ever imagined. Dried apricots are far healthier, sweet-dried fruits that can be enjoyed on their own as a satisfying snack or added to various dishes like salads, oatmeal, trail mix, or baked goods for a natural sweetness and nutritional boost. However, it's important to consume dried apricots in moderation due to their concentrated sugar content. Strawberries are delicious, sweet, and one of the most consumed fruits worldwide. But the question is, how can we have them fresh throughout the year? It has become more convenient since companies launched canned foods. This way, we can enjoy fresh strawberries all year round, even when they are not in season. Popping open a can and getting a burst of summer in every bite, either to top on your morning yogurt or blend into a smoothie, these beautiful fruits give you a lovely vibe. Honestly, these chickens are far more taken care of here, secure and cleaned, than in other local farms. Even in those large poultry facilities, they keep an eye on every chicken using robotic scanners, so they know every chicken is healthy, happy, and playing in advanced barns. Plus, did you notice those eggs systematically laying on the front row? That's how their automation works. It's all being observed and monitored until the eggs safely reach these units, where they will be tested for quality, etc. Here, the eggs automatically arrange for several inspections, like leak detection and cleaning purposes. Now comes this major egg inspector, which will approve only good eggs before they go into the disinfection chamber to remove any microorganisms or pathogens. And lastly, they are ready to come your way. No matter how some people oppose the idea of bottled juices, soft drinks, or any other processed liquids having a limited time at breakfast, I fall for those bottled and tasty juices every time. We all know it's not a healthy activity. I mean, it hardly takes 10 to 15 minutes to extract fresh juice. Anyway, that's not just my problem. The majority of us choose convenience. I'm glad we made it out successfully, most importantly, together. And please take good care of yourselves. You are precious. If we need to make that yummiest jam, we probably should focus on the healthy growth of the fruits too. Now this matter is being set under a strict guide. But yeah, giving those pots the healthier and fluffy mud with the precise amount of materials. Now these robots start at the bottom by planting strawberry plants in containers or pouches. Water is essential, so they water each pot carefully to keep the strawberries happy and hydrated. When the strawberries grow big and red, it's time to pick them. For this purpose, this gigantic robot activates its clutches to delicately pick the ripened strawberries only. Since they're on different levels, it's easy to reach and pluck the delicious berries. This entire automation is so beautiful and satisfying. How these robots peculiarly pick up the strawberry from the stem and cut it without harming it. In botanical terms, berries have their seeds inside the flesh, but strawberry seeds are on the outside, so they didn't consider it in the berry list. Those fresh strawberries have arrived at their final destination, and here they will get even royal treatment. just a little stop for a weight check. Once they make sure the demanded number of strawberries has arrived, they take them to the sorting units. And you better know what's going to be here with them. Of course, keeping you in mind, they're going to take that stack of strawberries for a manual check and make sure that only good quality strawberries are going further. Once they're sure of that, they let them pass on until they reach safe hands. Yep, these people are going to place each strawberry in that mold for the game-changing results. These robots automatically detect the green hull of a strawberry and beautifully just remove it without harming any other inch of the fruit. This is mind-blowing. Everything is under mechanical control. You can see how sharp eyes they have. Come on, they're doing this for you. Strawberries grow close to the ground, making them more susceptible to dirt, sand, and even tiny insects. The first wash, often a combination of water and little vibrations, removes these surface impurities. That's very important. But you know, fruits and veggies like these need another bath too. That's why they're given a second wash, often involving specialized sprays or misting with solutions like chlorine dioxide, which takes care of the tougher particles like pesticide residues and bacteria. This double trouble approach ensures the strawberries are as clean and safe as possible. They care about you. We care about you. See how honored we are to have you, just like these red, juicy strawberries. These fresh strawberries are now put into these containers. Yep, that's how you get the true and fresh flavor of frozen strawberries, because they are the same as, what to say, straight from farms to your plate. They are packed and firmly sealed to lock the pulpy fruit inside the food-grade containers. Just check out that large number of cans. Secondly, they use some of the frozen strawberries to make that glittery, yummy strawberry jam. All these frozen berries are put into the carriers to take them to the next stop, which is to load them into a container to add further ingredients. As the strawberries are loaded, now it's time to add further ingredients like sugar. They make sure the jam looks good, tastes good, and has the perfect texture. Once the handsome amount of sugar is poured, they need to control those figures and machines' capabilities by playing with some important buttons. The hot water tub is ready for these beautiful entities to enter and get bathed in the sweet syrup. What are they peeking at? Okay, the real drama has just begun. Once all the pulp comes to mix in that syrup, they put that material through sieves. This is important to give you that pulpless, smooth, jiggly jelly jam. Mixing, and more mixing. Everything is heated up in big pots or machines to make the strawberries blend and taste awesome. A special thing called pectin is added to make the jam just the right thickness. It's time to cook the material until it reaches its perfect texture, and that desired texture can be seen here. I think it's done. Yep, he's going to test the jam base to see if it's ready or needs to be cooked more. And yeah, it's good to go. Now the final process begins, to churn the mixture, to add a little more smoothness and to cool it side by side. A little now, it's like letting the flavors and texture settle and become best friends before they get packed into jars. And just wait, here we go. The whole warm jam base is ready. More close up here. It is, that creamy, smooth flow of my favorite jam. It's driving me crazy. Okay, time to pour that base and lock it in the jars. For that, these empty and starving bottles arrive. They are first neatly organized properly. The jam is carefully poured into jars all by itself. This process is usually automated in factories, with machines making sure each jar gets the right amount of fruity goodness. Here, we reach their sealing stage, where lots of lids are first picked in a proper style, beautifully conveyed to the roller coaster sort of belt, and finally to the sealing section where machines tightly seal the jars with lids. Okay, all those bottles are washed after being tightly sealed so that whatever sweetness remains on the outer side of the jars will be bathed away. We're now in the sticker section, where the robots will conveniently wrap stickers around these bottles so you will easily identify it's factory sealed. And of course, read that chart before eating anything. It's a good habit though. If you do, well, I don't. There's another technique too to add the labels one by one. All the bottles are labeled from whatever company they belong to and then piled up in the containers for the final bulk packaging. Bye-bye jam bottles. Don't forget my address and reach me soon. These mini jam bottles are filled up with the same freshness of fruit pulp and flavor to enrich your taste buds. Are those little nasty jam packets? You know, the ones at restaurants tucked next to the bread basket, bursting with fruity sunshine in one tiny bite. They're more than just sugar bombs. They might be tiny, but they're full of flavors to serve as starters for every meal. Also, these bite-sized marbles help stop food waste and make sure every spoonful is just right. These machines are the backbone of many industries, from food production to textile manufacturing to construction. With their robust blades and precise cutting mechanisms, they're built to tackle even the toughest materials. Imagine a scene where smoky aromas fill the air as meat sizzles on the grill, tantalizing taste buds with every flip and sear. Curious about the staggering output of flatbread producing machines in a single day? Prepare to be amazed. These efficient marvels can churn out an impressive number of flatbreads thanks to their high-speed capabilities and precision engineering. Depending on the size and capacity of the machine, production numbers can vary widely, ranging from thousands to even tens of thousands of flatbreads per day. Crafted with the finest ingredients and expert techniques, our pastries are a symphony of flavors and textures. Meet chocolate depositors, the sweet secret behind every delectable treat. Hazelnuts are packed with nutrients like protein, healthy fats, fiber, and various vitamins and minerals. Not only do they promote heart health and aid in weight management, but they also support brain function and contribute to healthy skin and hair. These little blue gems are packed with antioxidants, which help fight off harmful molecules in our bodies and keep us feeling great. Motivate us to create more satisfying videos like these and smash the like button. These factories aren't just about quantity, they're about crafting quality too, ensuring that each slice of salami delivers a burst of savory perfection. Removing the skin helps trim down on excess fat and calories. You see, much of the fat in chicken resides in the skin. So by peeling it off, you're opting for a leaner, healthier option. Additionally, without the skin acting as a barrier, marinades and seasonings can penetrate the meat more effectively, enhancing flavor throughout. Talking about almonds, you must eat them daily so you can remember us and keep watching our videos. Cheese holds a special place on plates globally, with millions indulging in its creamy goodness daily. Hey, if you're enjoying this video, make sure you hit that like button so we'll know how many people are interested in watching our upcoming videos. The ancient Egyptians were one of the first civilizations to enjoy sweets, using honey as a primary sweetener. That minced meat, also known as ground meat, is incredibly versatile and used in a wide array of dishes worldwide. From savory meatballs to juicy burgers, its adaptability knows no bounds. It all boils down to freshness and food safety. Ideally, you want to consume tray-sealed meat within a few days of purchase to ensure peak freshness and flavor. Let's crunch into the world of factory-made delicious potato chips. From sourcing the finest potatoes to adhering to strict quality control standards, these factories ensure that each chip meets the crispy, satisfying standard you expect. These machines are the backbone of large-scale food operations, capable of handling a wide variety of produce with speed and accuracy. These factory-prepared meals undergo stringent quality control measures to ensure they meet safety and nutritional standards. From automated sorting systems that ensure only the highest quality ingredients make it onto the production line to state-of-the-art packaging machines that swiftly seal products for freshness, these machines are essential for meeting consumer demand while maintaining high standards. Each pepper is carefully inspected for size, color, and quality, ensuring only the best make it to market. Each juicy bite is a refreshing explosion of tangy sweet goodness, leaving taste buds dancing with delight. These innovative contraptions are designed to streamline the process of pouring batter with precision and consistency. These machines are the masters of precision, effortlessly dispensing just the right amount of batter, dough, or filling with each press of a button. That's where the multi-head weighing machine shines. Its multiple weigh heads work simultaneously to ensure accuracy and efficiency. Imagine effortlessly removing the outer layer of fruits and vegetables with precision and finesse. That's the magic of these machines. From potatoes to oranges, they strip away the tedious task of manual peeling, saving you time and labor costs. But it's not just about convenience, it's about consistency. With peeling machines, you get uniform results every time, ensuring your products look as good as they taste. Wait, before watching this clip, were you thinking peeling fruit is the hardest thing to do? I mean, it's messy, but not anymore. It's not just about indulgence, there are benefits too. Chocolate breads pack a double punch of flavor and nutrition. Bursting with tropical flavor and juiciness, mangoes are nature's candy that never disappoints. From automated temperature control to efficient oil filtration systems, they're designed to optimize performance and minimize waste. Producing instant coffee in a factory is a complex process that combines food science, advanced engineering, and cutting-edge machinery to transform coffee beans into a soluble, ready-to-use product. From sourcing and roasting coffee beans to freeze drying or spray drying the brewed extract, each step in the production process is meticulously planned to ensure consistency, flavor preservation, and efficiency on a massive industrial scale. Let's take an in-depth look at the step-by-step factory process that goes into making instant coffee. The journey begins with sourcing green coffee beans. Factories procure these beans in large quantities from coffee-growing regions such as Brazil, Colombia, Vietnam, and Ethiopia. Since instant coffee requires consistent flavor profiles, manufacturers often blend beans from various regions to create a balanced and standardized flavor. Upon arrival at the factory, the green coffee beans are subjected to rigorous quality control checks. Samples are tested for size, moisture content, and defects to ensure the beans meet the factory's standards for processing. Once approved, the beans are stored in massive silos made of food-grade stainless steel or aluminum to protect them from contamination, pests, and humidity. These silos are equipped with automated systems that precisely dispense beans onto the production line. The first major step in processing the beans is cleaning. Coffee beans, even after being cleaned at their origin, may still contain impurities such as dirt, stones, sticks, or metal fragments. In the factory, the cleaning process involves several stages. Vibrating screens sift the beans to remove large debris, while air classifiers blow away lighter materials like husks or dust. Magnets are used to extract any metallic particles. Some factories also employ optical sorting machines, which use cameras and sensors to identify and remove defective beans or foreign objects. This thorough cleaning ensures that only high-quality beans proceed to the roasting stage. Roasting is a critical step in developing the rich, complex flavors of coffee. Factories use industrial coffee roasters, which can process thousands of pounds of beans per hour. The roasting process is controlled by highly advanced systems that allow operators to customize the roast profile for specific flavor outcomes. For instant coffee, medium to dark roasts are commonly used, as they bring out bold flavors that translate well into the final soluble product. Roasting temperatures typically range between 370 and 540 degrees Fahrenheit, depending on the desired flavor profile. During roasting, the beans undergo the Maillard reaction, a chemical process that creates the characteristic aromas and flavors of coffee. The roasting equipment includes temperature sensors and real-time monitoring systems to ensure uniform roasting across large batches. Once the roasting is complete, the beans are cooled rapidly to stop the roasting process and prevent overcooking. Factories use air cooling systems or water spray cooling, depending on the setup. Cooling is an important step, as improperly cooled beans can lose their flavor or become brittle. After cooling, the beans are sent to grinding machines. The grinding stage reduces the roasted coffee beans into smaller particles, which will be used for the brewing process. Factories use industrial grinders, such as roller mills or hammer mills, capable of producing a consistent grind size. The grind size is crucial because it affects the extraction process that follows. For instant coffee, a relatively coarse grind is typically used to optimize the brewing process in the factory. The ground coffee is then stored in intermediate holding bins, where it is kept fresh until it is ready to be brewed. Brewing is the next major step in instant coffee production, and it is carried out on an industrial scale. Massive brewing systems, similar to oversized percolators, are used to extract the soluble compounds from the ground coffee. These systems consist of large stainless steel extraction tanks or columns, which are designed to hold thousands of gallons of water and coffee grounds. Hot water is circulated through the coffee grounds at precise temperatures and pressures, mimicking the brewing process used at home, but on a much larger scale. Typically, water temperatures range between 190 and 205 degrees Fahrenheit, and the brewing time is carefully controlled to maximize flavor extraction while minimizing bitterness. The brewed coffee concentrate, a liquid containing the extracted soluble compounds, is then filtered to remove the spent coffee grounds. Factories use advanced filtration systems, such as centrifugal separators or fine mesh filters, to ensure that no solid particles remain in the liquid. The spent grounds are often dried and repurposed as fertilizer or biomass fuel, making use of every part of the raw material. At this stage, the coffee concentrate is a highly aromatic liquid, but it is still far from the final product. The challenge is to transform this liquid concentrate into a stable, dry, and soluble form. Factories use one of two main methods for this: spray drying or freeze drying. Spray drying is a fast and cost-effective method that is commonly used to produce instant coffee powder. The coffee concentrate is first preheated to reduce its moisture content. It is then pumped into a tall, spray drying chamber equipped with nozzles that disperse the liquid into fine droplets. At the same time, hot air, typically around 480 degrees Fahrenheit, is blown into the chamber. As the droplets fall through the chamber, the water in the coffee concentrate rapidly evaporates, leaving behind fine coffee powder. Spray drying is efficient and capable of processing large volumes, but the high temperatures can sometimes lead to a slight loss of flavor and aroma. Freeze drying, on the other hand, is a more delicate and sophisticated process that better preserves the natural flavors and aromas of coffee. The coffee concentrate is first frozen at extremely low temperatures, usually around 40 degrees Fahrenheit, to form solid slabs or granules. These frozen coffee pieces are then placed in a vacuum chamber. Inside the chamber, the frozen water in the coffee undergoes sublimation, a process where ice turns directly into vapor without passing through the liquid phase. This method requires precise control of temperature and pressure and takes longer than spray drying, but it produces high-quality granules of instant coffee that dissolve easily in water. After the drying process, the instant coffee is sifted and graded by particle size to ensure uniformity. Any oversized or undersized particles are removed, and the coffee is blended to create a consistent final product. Factories conduct rigorous quality control tests at this stage, including flavor analysis, solubility testing, and moisture content measurement. These tests ensure that the instant coffee meets the desired standards for flavor, aroma, and texture. Packaging is the final step in the production process, and it is designed to protect the coffee from moisture and preserve its freshness. The dried instant coffee is transported to high-speed filling machines, which dispense precise amounts of coffee into jars, tins, or pouches. Factories use nitrogen flushing systems to replace oxygen in the packaging, as oxygen can degrade the coffee over time. The jars are sealed with airtight lids, while pouches are heat-sealed to maintain freshness. After sealing, the packages move to labeling stations, where automated systems apply branding, ingredient lists, and expiration dates. Each package undergoes a final inspection using vision systems to ensure there are no defects in the seals or labels. Once approved, the packages are packed into cartons or cases using robotic packing systems and prepared for shipping. Pallets of instant coffee are stacked and wrapped for stability before being loaded onto trucks or containers for global distribution. Throughout the entire process, factories rely on advanced automation and engineering to ensure efficiency and consistency. Programmable logic controllers and supervisory control and data acquisition systems monitor and control every stage of production, from roasting and brewing to drying and packaging. Real-time data on temperature, pressure, humidity, and other parameters allows operators to make precise adjustments as needed, minimizing waste and ensuring high-quality output. Hygiene and food safety are also paramount in instant coffee production. Production areas are designed with food-grade stainless steel surfaces, seamless flooring, and clean room environments to prevent contamination. Positive air pressure systems are used to keep airborne particles out of critical areas, and employees are required to follow strict hygiene protocols, including wearing protective clothing and adhering to cleaning schedules. Factories are regularly inspected and certified to meet international food safety standards. Inside a tea factory, the transformation of fresh tea leaves into the familiar tea bags, loose leaf tea, or powdered varieties is a carefully orchestrated process. It is a seamless blend of tradition, precision engineering, and science. Every step of the way, from leaf intake to packaging, is designed to preserve the flavor, aroma, and quality that tea enthusiasts have come to expect. While the type of tea being produced, whether black, green, oolong, or white, dictates specific steps in the process, the overall journey is one of meticulous attention to detail, where both manual expertise and advanced machinery play vital roles. The process begins at the tea gardens, where leaves from the Camellia sinensis plant are plucked at peak quality. For most teas, workers handpick only the top 2 leaves and a bud from each branch, as these tender parts of the plant produce the best flavor and aroma. After harvesting, the leaves are transported to the factory as quickly as possible to prevent spoilage or fermentation during transit. Many tea factories are strategically located near plantations to minimize delays and ensure freshness. Upon arrival at the factory, the tea leaves are weighed and inspected for quality. Modern tea factories are equipped with automated intake systems that separate leaves from debris such as twigs or foreign matter. Vibrating conveyor belts or mechanical sieves are commonly used at this stage to remove unwanted materials. For higher grade teas, additional manual inspections may be carried out to ensure only the finest leaves proceed to the next step. The fresh leaves are then carefully spread out in thin layers on large trays or conveyor belts, marking the beginning of the first stage in tea processing. Withering. Withering is a critical step in tea production, as it reduces the moisture content of the fresh tea leaves and prepares them for the subsequent stages of processing. In the factory, withering is typically carried out in withering troughs, long, shallow trays equipped with a system of fans and controlled airflow. Fresh tea leaves are laid out on these trays, and air is circulated over them for several hours to slowly remove moisture. For black tea, withering may last anywhere from 12 to 18 hours, while green tea requires a shorter withering time, as it needs to retain more of its fresh, grassy flavor. Temperature and humidity are carefully controlled using automated climate systems to ensure consistent results. During this stage, the leaves become softer and more pliable, making them ready for rolling. The next stage is rolling, where the tea leaves are twisted and shaped to release their essential oils and initiate oxidation if required, as with black and oolong teas. Factories use large mechanical rolling machines equipped with heavy, grooved plates or rollers. These machines apply pressure to the leaves, breaking down their cell walls and releasing their natural juices. The released juices react with oxygen in the air, beginning the oxidation process that gives black tea its characteristic flavor and color. Rolling machines can be adjusted to produce different shapes and textures depending on the type of tea being made. For example, green teas may be rolled into tight pellets for varieties like gunpowder tea, while black teas are often left in long, wiry shapes. At this point, the production process diverges depending on the type of tea being manufactured. For black tea, oxidation is the next key step. Oxidation, often mistakenly referred to as fermentation, is a chemical process that darkens the tea leaves and develops the rich, robust flavors associated with black tea. In factories, oxidation typically takes place in large, temperature-controlled rooms, where rolled tea leaves are spread out on trays or conveyor belts. These rooms maintain a controlled environment with high humidity and a temperature of around 77 to 86 degrees Fahrenheit. The leaves are periodically monitored to ensure they achieve the desired level of oxidation, which can take anywhere from 30 minutes to several hours, depending on the tea. As the leaves oxidize, they turn from green to a reddish-brown color, releasing the aromatic compounds that define black tea. In contrast, for green tea production, oxidation is intentionally prevented. To preserve the vibrant green color and fresh vegetal flavor of the leaves, factories employ a process called fixation, also known as kill green. This step involves heating the leaves immediately after rolling to deactivate the enzymes that cause oxidation. Factories use either steam or dry heat for this purpose. For Japanese-style green teas, like sencha, the leaves are steamed in specialized machines, while Chinese-style green teas are often pan-fried in large heated woks or rotating drum roasters. Fixation requires precise temperature control, as overheating can burn the leaves and underheating can fail to stop oxidation completely. Once oxidation or fixation is complete, the next step is drying, which reduces the moisture content of the tea to make it shelf stable. Drying is typically carried out in large industrial dryers or ovens equipped with temperature controls and airflow systems. Conveyor belt dryers, in which the leaves are gradually moved through a heated chamber, are common in large-scale tea factories. The temperature during drying ranges from 194 to 248 degrees Fahrenheit, depending on the type of tea and the desired final moisture content, which is usually around 3 to 5%. This step is crucial for locking in the flavor and aroma of the tea while ensuring it will not spoil during storage. After drying, the tea leaves are sorted and graded. In the sorting process, leaves are separated by size, shape, and quality using a combination of vibrating sieves, air separators, and optical sorting machines. Whole leaves, broken leaves, and small particles are separated into different grades, which are used for various tea products. For instance, whole leaves are often reserved for premium loose-leaf teas, while smaller particles are used for tea bags. Some factories also employ advanced laser sorting machines that can detect and remove any remaining foreign objects or off-spec leaves. Blending is another key step in tea production, especially for brands that aim to create consistent flavor profiles. Many teas are blended by mixing leaves from different regions, harvests, or even types of tea. Blending is carried out in large rotating drums or mixing machines, where precise quantities of different teas are combined to achieve the desired flavor. For flavored teas, additional ingredients such as dried fruit pieces, herbs, or essential oils are added during this stage. For example, Earl Grey tea is made by blending black tea leaves with bergamot oil, while chai blends often include spices like cinnamon, cardamom, and cloves. Once the tea has been blended and sorted, it is ready for packaging. Packaging is a highly automated process in modern tea factories. For loose-leaf tea, the leaves are weighed and sealed in airtight bags, tins, or foil-lined pouches to preserve freshness. For tea bags, the leaves are measured and packed into filter paper, which is then cut and sealed into individual tea bags using high-speed machines. Many factories also produce pyramid-shaped tea bags, which allow for larger leaves and better infusion. After filling, the tea bags are placed into cartons or boxes, which are sealed and labeled with branding, lot numbers, and expiration dates. Throughout the entire process, quality control plays a vital role in ensuring the tea meets rigorous standards. Factories employ trained tea tasters who sample the tea at various stages of production to assess its flavor, aroma, and appearance. Advanced laboratory equipment is also used to measure moisture content, microbial activity, and other parameters that affect the quality and safety of the final product. Additionally, factories must comply with food safety regulations and certifications, such as ISO 22000 or HACCP, to ensure their tea is safe for consumption. Cocoa powder, the cornerstone of countless recipes from rich chocolate cakes to creamy hot cocoa, is the product of a complex and fascinating manufacturing process that combines agricultural expertise with advanced industrial engineering. Behind every tin or packet of cocoa powder lies a detailed, multi-step operation where raw cacao beans are transformed into the fine, flavorful powder that has become a staple ingredient in kitchens around the world. This process begins on cacao farms and culminates in a factory where specialized equipment and precise techniques ensure the consistency, flavor, and quality of the finished product. Let's take an in-depth journey into how cocoa powder is made, exploring each stage of the process, from bean to powder. The story of cocoa powder begins with the cacao tree, which thrives in tropical regions near the equator, such as West Africa, Southeast Asia, and Central and South America. The cacao tree produces pods that contain cacao beans surrounded by a sweet, sticky pulp. These beans are the raw material for cocoa powder. Once harvested, the pods are split open to extract the beans, which are then immediately subjected to the first critical step in the process: fermentation. Fermentation is a natural and essential process that develops the flavor precursors in cacao beans. After being removed from the pods, the beans and their surrounding pulp are placed into shallow wooden boxes or large banana leaf-lined baskets, where they ferment over a period of 5 to 7 days. During this time, natural yeasts and bacteria break down the sugars in the pulp, generating heat and causing the temperature in the fermentation pile to rise significantly, often reaching over 120 degrees Fahrenheit. This heat triggers a series of chemical reactions within the beans, developing their characteristic chocolate flavor while reducing bitterness. The beans are turned periodically to ensure even fermentation and prevent spoilage. Once fermentation is complete, the beans are removed from the boxes or baskets and sent to the next stage: drying. Drying is critical for stabilizing the fermented beans and reducing their moisture content to a level suitable for storage and transport. Traditionally, cacao beans are dried under the sun, spread out in thin layers on large drying racks or patios, and turned regularly with wooden rakes to ensure even drying. In modern cocoa production, factories may use mechanical dryers when weather conditions are unsuitable for sun drying or to speed up the process. These machines blow heated air over the beans to achieve the target moisture content, which is usually around 6 to 7%. Proper drying is essential because any excess moisture could lead to mold growth during storage or shipping. Once dried, the beans are sorted, graded, and packed into jute bags or bulk containers, ready for shipment to processing facilities. Upon arriving at the cocoa processing factory, the dried cacao beans are carefully inspected for quality. Factories use advanced optical sorting machines equipped with cameras and lasers to identify and remove defective beans, such as those that are cracked, moldy, or undersized. Any remaining debris, like stones or twigs, is removed using vibrating screens and air separators. Once the beans are cleaned, they are stored in large silos made of food-grade stainless steel, which protects them from contamination while allowing for easy access as the beans move through the production line. The first step inside the factory is roasting, a critical stage that brings out the rich chocolatey aroma and flavor of the beans. Industrial roasters are designed to handle large volumes of cacao beans, roasting them at precise temperatures that can range from 250 to 300 degrees Fahrenheit. The exact temperature and duration of roasting depend on the type of cocoa powder being produced, as darker roasts develop more intense flavors, while lighter roasts preserve subtle fruity or floral notes. During roasting, the shells of the beans become brittle, and the internal nibs, which contain the cocoa solids and cocoa butter, begin to separate from the shell. Sensors and computer-controlled systems monitor the roasting process to ensure consistency across batches. Once roasting is complete, the beans are rapidly cooled, using air or water to prevent overcooking. The next stage is winnowing, where the roasted beans are cracked open to separate the nibs from the outer shells. This process is carried out using winnowing machines, which use a combination of mechanical rollers and air currents to break the shells and blow them away. The result is a pile of clean, roasted nibs, which are the purest form of cacao and the raw material for all cocoa products. The nibs are then ground into a thick, viscous liquid known as cocoa liquor, despite containing no alcohol. The grinding process involves heavy-duty industrial grinders, such as roller mills or stone grinders, which crush the nibs into tiny particles. This process releases the natural cocoa butter within the nibs, creating a smooth liquid that flows easily. The particle size is reduced to less than 30 microns during this stage to ensure a silky texture. Cocoa liquor is the base ingredient for many chocolate products, but for cocoa powder production, the focus shifts to separating the two main components of the liquor, cocoa solids and cocoa butter. The separation of cocoa solids and cocoa butter is achieved through pressing. Cocoa liquor is fed into hydraulic or screw presses, which apply immense pressure, up to 6,000 pounds per square inch, to squeeze out the cocoa butter. This process leaves behind a solid cake of compressed cocoa solids. The extracted cocoa butter is collected and filtered for use in other products, such as chocolate bars, cosmetics, or pharmaceuticals. Meanwhile, the cocoa cake, which still contains a small amount of residual fat, becomes the foundation for cocoa powder. The cocoa cake is cooled and broken into smaller chunks before being fed into pulverizing machines, where it is ground into a fine powder. Factories use various types of grinding equipment, such as pin mills or ball mills, to achieve the desired particle size for cocoa powder. This step is critical for ensuring that the final product has a consistent texture and dissolves easily in liquids. The fineness of cocoa powder can vary depending on its intended use. For example, baking-grade cocoa powder is typically ground finer than drinking cocoa. At this point, the cocoa powder is almost ready, but one additional process may take place depending on the type of cocoa being produced: alkalization, also known as Dutch processing. Alkalization involves treating the cocoa powder with an alkaline solution, such as potassium carbonate. This process neutralizes the natural acidity of the cocoa, darkens its color, and gives it a smoother, milder flavor. Alkalized cocoa powder is often used in baking and beverages, as its reduced acidity reacts differently with leavening agents like baking soda. Once the cocoa powder is fully processed, it undergoes rigorous quality control tests to ensure it meets the manufacturer's standards. Samples are tested for flavor, color, pH levels, fat content, and particle size. Factories use advanced laboratory equipment, such as spectrophotometers and viscometers, to measure these properties with precision. Any deviations from the desired specifications are identified and corrected before the product moves to the packaging stage. Packaging is the final step in the production process, and it plays a critical role in preserving the freshness and quality of the cocoa powder. The powder is first sifted to remove any clumps or oversized particles, ensuring a uniform texture. It is then transferred to automated filling machines, which dispense precise amounts of cocoa powder into containers, such as tins, pouches, or bulk bags. For retail packaging, the containers are often flushed with nitrogen gas before sealing to remove oxygen and prevent spoilage. Labels are applied to the packages, including information such as the brand, product type, lot number, and expiration date. Once packaged, the cocoa powder undergoes a final round of inspections, where advanced vision systems check for defects such as improper sealing, misaligned labels, or damaged containers. The finished products are then packed into cartons or cases using robotic packaging systems. Palletizing robots stack the cartons neatly onto pallets, which are shrink-wrapped for stability and loaded onto trucks or shipping containers for distribution. To create the world's most beloved hazelnut and cocoa spread, the manufacturing facilities are equipped with advanced machinery, precision-engineered systems, and rigorous quality controls. Each step in the process is optimized for efficiency, consistency, and the highest standards of food safety. In this detailed breakdown, we'll explore how Nutella is made inside a modern factory, from the raw materials to the final product, with a close look at the construction, operation, and technical aspects of the factory's systems and machinery. The process begins with the sourcing of raw ingredients, including hazelnuts, sugar, cocoa powder, palm oil, skim milk powder, and vanillin. These ingredients are delivered to Nutella factories in massive quantities, requiring large-scale handling infrastructure. Hazelnuts, one of the key components of Nutella, are often sourced from Turkey and Italy, two of the largest hazelnut producers in the world. Upon arrival at the factory, hazelnuts are stored in enormous silos or temperature-controlled storage rooms to maintain their freshness. The silos are made of food-grade stainless steel and designed to protect the nuts from humidity and contamination, while allowing for precise dispensing into the production line. The first step in processing the hazelnuts is cleaning. Hazelnuts arrive in bulk shipments, often mixed with debris such as shells, stems, and dirt. To address this, the factory uses a series of cleaning systems that include vibrating screens, air classifiers, and magnetic separators. The vibrating screens shake the nuts to separate them from larger debris, while the air classifiers blow away lightweight impurities like husks and dust. Magnetic separators are also used to detect and remove any metallic particles that might have entered the shipment during harvesting or transport. Once cleaned, the hazelnuts undergo visual inspection using high-speed optical sorting machines equipped with cameras and sensors. These machines identify and remove any defective hazelnuts, such as those with discoloration, cracks, or signs of mold. After cleaning, the hazelnuts move to the roasting stage. Roasting is a crucial step in developing the rich, nutty flavor that characterizes Nutella. In the factory, this is achieved using massive industrial roasting ovens. These ovens are designed with rotating drums or conveyor belts to ensure even roasting. The temperature is carefully controlled, typically ranging between 280 and 320 degrees Fahrenheit, depending on the size and moisture content of the hazelnuts. Sensors monitor the temperature and time to ensure consistency, as over-roasting can lead to bitterness, while under-roasting can result in a lack of flavor. The entire roasting process is automated, and the equipment is designed for continuous operation to handle the high volume of hazelnuts required for production. Once roasted, the hazelnuts are transferred to grinding machines. These machines are equipped with heavy-duty stainless steel blades and rollers that crush the nuts into a fine paste. The grinding process occurs in multiple stages, with each stage further reducing the particle size of the hazelnut paste. In the initial stage, the nuts are coarsely ground into a chunky paste. In the subsequent stages, the paste is refined into a smooth consistency, with particle sizes measuring less than 30 microns. This ultra-fine grinding is essential for achieving Nutella's creamy texture. The equipment used in this process, such as colloid mills and ball mills, is highly specialized and designed to operate under high pressure and at precise speeds. The resulting hazelnut paste is collected in large stainless steel tanks, where it is stored at a controlled temperature to preserve its flavor and consistency. While the hazelnut paste is being prepared, the other ingredients are processed in parallel. Sugar, which provides sweetness to Nutella, is delivered to the factory in bulk containers or tankers. Upon arrival, the sugar is unloaded into silos, equipped with pneumatic conveying systems. These systems use air pressure to transport the sugar from the silos to the milling area, where it is ground into a fine powder. Industrial sugar mills are used for this purpose, and the grinding process ensures that the sugar particles are small enough to dissolve uniformly in the mixture. The factory also incorporates sieving systems to filter out any impurities or oversized sugar particles before they proceed to the blending stage. Cocoa powder, another key ingredient, undergoes a similar process. The cocoa powder is stored in sealed silos to protect it from moisture and contamination. Before being added to the Nutella mixture, the cocoa powder is sifted through vibrating screens to break up clumps and ensure a fine, even consistency. This step is crucial for achieving the smooth texture of the final product, as any clumps could create inconsistencies during blending. Palm oil, which gives Nutella its creamy consistency and prevents separation, is stored in large, temperature-controlled tanks. These tanks are equipped with heating elements to keep the oil in a liquid state, as palm oil tends to solidify at room temperature. The oil is pumped through insulated pipes to the mixing area, where it is carefully measured and added to the blend. The precise control of temperature and flow rate is essential to ensure that the oil integrates smoothly with the other ingredients. Skim milk powder, which adds a subtle dairy flavor and contributes to the creamy texture of Nutella, is stored in sealed containers or silos to prevent exposure to air and moisture. Before being used, the milk powder is sifted and screened to remove any lumps. Factories use advanced pneumatic conveying systems to transport the milk powder from the storage silos to the mixing area, ensuring that the ingredient is handled efficiently and hygienically. The blending process is the heart of Nutella's production, where all the prepared ingredients come together to form the final product. The blending tanks used in Nutella factories are massive, often with capacities of several thousand gallons. These tanks are equipped with high-speed agitators and temperature control systems. The hazelnut paste, sugar powder, cocoa powder, skim milk powder, palm oil, and vanillin are added to the tank in precise proportions, which are controlled by computerized dosing systems. These systems are programmed to weigh and dispense each ingredient accurately, ensuring consistency across batches. During blending, the mixture is heated slightly to help the ingredients combine more effectively. The temperature is carefully monitored, as excessive heat could alter the flavor and texture of the product. The blending tanks are designed to ensure even mixing, with agitators that create a vortex to incorporate all the ingredients thoroughly. The result is a homogeneous mixture with a smooth, creamy consistency. Once the blending process is complete, the mixture undergoes a refining stage. Refining is a critical step that ensures the final product is free of any graininess. The refining process takes place in multi-stage roller mills, which are equipped with heavy-duty steel rollers. These rollers apply immense pressure to the mixture, reducing the particle size of any remaining solids to less than 20 microns. This process not only enhances the texture of Nutella, but also improves its spreadability. The roller mills are fitted with precision sensors that monitor the pressure and temperature during refining, ensuring optimal performance. After refining, the mixture is transferred to the conching stage. Conching is a process borrowed from chocolate manufacturing and involves agitating the mixture in large, heated tanks for several hours. This process helps to further smooth the texture and enhance the flavor of the spread by allowing volatile compounds to evaporate and by evenly distributing the fats and solids. The conching tanks are equipped with paddles or rollers that knead the mixture continuously. The temperature and duration of conching are carefully controlled, as over-conching could negatively affect the spread's consistency. The finished Nutella is then pumped into holding tanks, where it is kept at a controlled temperature until it is ready for packaging. These tanks are equipped with agitators to prevent separation and maintain the spread's uniformity. Before the Nutella is packaged, it undergoes a final round of quality control. Samples from each batch are tested for flavor, texture, color, and viscosity. The factory uses advanced laboratory equipment such as viscometers and spectrophotometers to ensure that the product meets the company's stringent standards. Any deviations from the desired specifications are identified and corrected before the product proceeds to the packaging stage. Packaging is the final step in Nutella's production process, and it is carried out with the same level of precision and efficiency as the earlier stages. The spread is pumped from the holding tanks into automated filling machines, which dispense precise amounts of Nutella into jars. The filling machines are equipped with high-speed nozzles that can fill hundreds of jars per minute. Each jar is made from food-grade plastic or glass and arrives at the factory pre-sterilized to ensure hygiene. The jars are sealed with tamper-proof lids, which are applied and tightened using automated capping machines. Once the jars are sealed, they are conveyed to labeling stations, where Nutella's iconic branding is applied. The labels include important information such as the lot number, production date, and expiration date, which are printed using high-speed inkjet or laser printers. After labeling, the jars are inspected by vision systems that check for defects such as misaligned labels or damaged seals. Any defective jars are automatically removed from the production line. The jars are then packed into cardboard cartons using robotic packing systems. These systems are programmed to arrange the jars in specific configurations to maximize space and protect the jars during transportation. The cartons are sealed and stacked onto pallets using robotic palletizers. The pallets are then wrapped in plastic film for stability and loaded onto trucks or shipping containers for distribution. The entire packaging process is designed for high efficiency, with minimal manual intervention and maximum output. Throughout the factory, automation plays a key role in maintaining efficiency and consistency. Programmable logic controllers and supervisory control and data acquisition systems are used to monitor and control every aspect of the production process. These systems provide real-time data on parameters such as temperature, pressure, and flow rates, allowing operators to make adjustments as needed. The factory is also equipped with advanced robotics and machinery that ensure smooth operation, from ingredient handling to final packaging. Hygiene and safety are top priorities in Nutella factories. Production areas are constructed with food-grade stainless steel surfaces and epoxy-coated floors that are easy to clean and sanitize. Air filtration systems maintain a clean environment by preventing airborne contaminants from entering critical zones. Employees follow strict hygiene protocols, including wearing protective clothing and washing their hands regularly. The factory is regularly inspected to ensure compliance with international food safety standards, guaranteeing that every jar of Nutella is safe for consumption. This intricate, highly automated process ensures that Nutella is consistently smooth, flavorful, and delicious, meeting the high expectations of its millions of fans worldwide. Every step, from the handling of raw ingredients to the final packaging, is a testament to the engineering and precision that go into creating this beloved spread. The result is a product that continues to delight consumers, one jar at a time. Peanut butter, a staple spread beloved worldwide for its creamy or crunchy texture, requires a sophisticated and highly organized manufacturing process to meet the demand for consistent quality and flavor. Behind every jar of peanut butter is an intricate factory process that starts with the raw peanuts and ends with precisely packaged jars ready for distribution. Let's take an in-depth look at the factory production process, exploring the machines, systems, and engineering techniques that make it all possible. The process begins with the sourcing of raw peanuts. These peanuts are typically grown in countries like the United States, China, India, and Argentina, which are among the largest producers of peanuts globally. Peanuts are harvested in vast quantities, cleaned and dried at their source before being shipped to peanut butter manufacturing facilities. Factories require a consistent supply of high-quality peanuts, and to ensure that the raw peanuts are often tested upon arrival for size, moisture content, and overall quality. This ensures only the best peanuts are used for processing. Upon arrival at the factory, peanuts are stored in massive silos, or bins, designed specifically for food products. These silos are constructed from food-grade stainless steel or coated steel to prevent contamination and ensure proper hygiene. Inside the silos, the peanuts are protected from moisture, pests, and temperature fluctuations. These storage systems are equipped with conveyor systems that efficiently transfer peanuts from the silos to the initial cleaning and processing stages. The first step in processing peanuts is cleaning. Even though peanuts are partially cleaned at their source, factories implement a rigorous cleaning process to ensure no foreign materials or impurities remain. Vibrating screens are used to remove debris such as dirt, stones, and small sticks. Air classifiers blow air through the peanuts to remove lighter debris such as peanut skins or husks. Magnets are also employed to extract any metallic impurities. Optical sorting machines equipped with cameras and sensors scan each peanut as it moves along a conveyor belt, automatically removing any defective peanuts, including those with discoloration, mold, or deformities. After the cleaning process, the peanuts proceed to the roasting stage. Roasting is a critical step in peanut butter production, as it develops the rich, nutty flavor that defines the final product. Factories use industrial roasting ovens to roast the peanuts at controlled temperatures. These ovens come in two main types: batch roasters and continuous roasters. Batch roasters are used for smaller production lines, while continuous roasters, which use conveyor belts to move peanuts through a heated chamber, are used for larger scale operations. The temperature in these roasters typically ranges from 300 to 350 degrees Fahrenheit. The roasting process is closely monitored with temperature sensors and automated control systems to ensure the peanuts are roasted evenly. If some peanuts are over-roasted, they can turn bitter, while under-roasted peanuts may lack flavor. The level of roasting can also be adjusted depending on whether the final peanut butter will have a mild or more robust taste. Once roasted, the peanuts are cooled to stop the cooking process. Cooling is achieved by passing the roasted peanuts through chambers with powerful fans or cool air blowers. This step is crucial because it prevents the peanuts from continuing to cook, which could lead to inconsistencies in flavor. Some factories also use a water spray system to rapidly cool the peanuts, though this is less common as it can add moisture to the product. The cooling systems are designed to operate continuously to keep pace with the output of the roasting ovens. With the peanuts roasted and cooled, the next step is to remove their skins and separate the kernels. Skin removal is done using blanching machines. These machines have rotating drums or abrasive rollers that rub the peanuts, causing the thin outer skin to flake off. Some systems use steam blanching, where the peanuts are exposed to high-pressure steam to loosen the skins before mechanical removal. After blanching, the peanuts pass through air classifiers that blow away the loose skins, leaving behind clean peanut kernels. Factories also use gravity separators to sort peanuts by size and density, ensuring that only uniform peanuts proceed to the grinding stage. Before grinding, the peanuts are inspected again for quality. This is done using high-speed optical sorters that ensure any remaining defective peanuts are removed. Factories often have automated weighing and proportioning systems at this stage to determine the exact amount of peanuts needed for each batch. This level of precision is crucial for maintaining consistency in the flavor and texture of the peanut butter. The grinding process is the heart of peanut butter production. The roasted peanuts are fed into industrial grinders, where they are crushed into a fine paste. This process happens in multiple stages, beginning with coarse grinding and followed by finer grinding. The equipment used for this includes hammer mills and roller mills, which are specifically designed to reduce the peanuts into small, uniform particles. In many factories, the particle size is reduced to less than 20 microns, which is smaller than the diameter of a human hair. Achieving such a fine consistency is essential for the creamy texture that many consumers expect from peanut butter. For crunchy peanut butter, the process is slightly different. In these cases, a portion of the peanuts is coarsely ground and set aside before the final blending stage. These larger peanut pieces are later mixed into the smooth paste to create the characteristic crunchy texture. To prevent the peanut butter from separating, stabilizers such as hydrogenated vegetable oils or palm oil are added during the grinding process. These oils help bind the natural peanut oils to the solid peanut particles, ensuring a smooth and stable product that doesn't separate in the jar. Salt and sugar are also added at this stage to enhance the flavor of the peanut butter. Factories use precision dosing systems to measure and add these ingredients in exact proportions, ensuring every batch has the same taste. After grinding, the peanut butter is sent through a mixing stage, where it is further blended in large stainless steel tanks equipped with high-speed agitators. This stage ensures that the stabilizers, salt, and sugar are evenly distributed throughout the peanut butter. These tanks are often heated slightly to keep the peanut butter at the right consistency for mixing. The temperature is carefully controlled, as overheating can alter the flavor or texture of the peanut butter. Once the mixing is complete, the peanut butter undergoes quality control checks. Samples from each batch are tested in an on-site laboratory for flavor, texture, and consistency. Advanced instruments, such as viscometers, are used to measure the viscosity of the peanut butter, ensuring it meets the desired standards. Factories also use particle size analyzers to confirm that the peanut butter's texture is smooth and uniform. These quality checks are critical, as even slight variations can impact the final product's appeal to consumers. The final step in the manufacturing process is packaging. The peanut butter is pumped from the mixing tanks to filling machines, where it is dispensed into jars. These filling machines are capable of handling thousands of jars per hour, ensuring high efficiency. The jars, typically made of food-grade plastic or glass, arrive at the factory pre-cleaned and are sterilized again before filling. The filling nozzles are designed to dispense precise amounts of peanut butter into each jar, ensuring uniform weight and volume. Once the jars are filled, they move to the capping machines, where tamper-proof lids are applied and tightened. After capping, the jars are conveyed to labeling machines, which apply the brand's signature labels, along with lot numbers and expiration dates for traceability. Vision systems inspect each jar to ensure that the labels are correctly applied and that there are no defects in the seals or packaging. The jars are then packed into cardboard boxes using robotic packing systems. These robots are programmed to arrange the jars in specific configurations to optimize space and protect the jars during transportation. The boxes are sealed and stacked onto pallets using automated palletizing systems. Finally, the pallets are wrapped in plastic film for stability and loaded onto trucks or shipping containers for distribution. Throughout the entire production process, automation plays a vital role in maintaining efficiency and consistency. Factories are equipped with programmable logic controllers, PLCs, and supervisory control and data acquisition, SCADA systems, that monitor and control every aspect of production. These systems provide real-time data on parameters such as temperature, pressure, and flow rates, allowing operators to make adjustments as needed. Robotic systems handle many tasks, from sorting and cleaning peanuts to packaging the final product, reducing the need for manual labor and ensuring precision. Hygiene and safety are also top priorities in peanut butter factories. The production areas are constructed with food-grade stainless steel surfaces and epoxy-coated floors that are easy to clean and sanitize. Positive air pressure systems prevent airborne contaminants from entering critical zones, while strict hygiene protocols ensure that employees maintain cleanliness throughout the production process. The entire facility is regularly inspected to comply with international food safety standards, ensuring that every jar of peanut butter is safe for consumption. Peanut butter production is a complex and highly technical process that relies on advanced machinery, precise engineering, and rigorous quality control. From the cleaning and roasting of peanuts to the grinding, mixing, and packaging of the final product, every step is designed to create a spread that is smooth, flavorful, and consistent. Factories operate with remarkable efficiency, producing thousands of jars per day to meet the global demand for this versatile and beloved product. Strawberry jam production is a fascinating and highly engineered process that combines precision machinery with time-tested techniques to create a smooth, fruity spread. At the core of this process are high-quality strawberries, sugar, pectin, and citric acid, all carefully handled and processed to achieve the perfect consistency and flavor. Inside a modern jam factory, every step is optimized for efficiency, consistency, and food safety. The process begins with the selection and delivery of fresh or frozen strawberries. Factories typically source strawberries from local farms or large-scale suppliers. Frozen strawberries are often preferred for large-scale production because they are preserved at peak ripeness, ensuring consistent flavor year-round. The strawberries arrive in bulk containers and are stored in cold rooms or freezers to maintain their quality until processing begins. Before entering the production line, the fruit undergoes a thorough cleaning process. This includes washing the strawberries in large tanks filled with filtered water, where gentle agitation removes dirt, debris, and any residual pesticides. Once cleaned, the strawberries pass through optical sorting machines. These machines use cameras and sensors to identify and remove defective or discolored fruit. Advanced systems can even detect minute imperfections, ensuring that only the highest quality strawberries make it into the jam. After sorting, the strawberries are sent to cutting or mashing machines, depending on the desired jam texture. For chunkier jams, strawberries are coarsely chopped, while for smooth spreads, they are mashed or pureed into a uniform consistency. The fruit then enters large stainless steel cooking kettles or continuous cooking systems. In these vessels, the strawberries are combined with sugar, which not only sweetens the jam, but also acts as a natural preservative. The sugar is added using automated dosing systems that measure precise quantities to ensure consistent flavor. Pectin, a natural thickening agent derived from fruit, is added to help the jam set. Citric acid is also incorporated to balance the sweetness and enhance the fruit's natural flavor. The mixture is slowly heated, with temperatures reaching up to 220 degrees Fahrenheit to activate the pectin and achieve the ideal gel-like consistency. During cooking, the jam undergoes constant agitation to prevent scorching and ensure even heating. Steam-jacketed kettles or vacuum cookers are often used, as they allow for rapid and uniform heating. Modern vacuum systems are particularly advantageous because they enable cooking at lower temperatures, preserving the fresh flavor and bright color of the strawberries. Throughout the cooking process, sensors monitor the temperature, pH levels, and viscosity of the jam, ensuring that the final product meets strict quality standards. Once the jam reaches the desired consistency, it is pumped through a series of filters to remove any seeds or large pieces if a smoother texture is desired. The finished jam is then transferred to filling machines. These machines dispense precise amounts of jam into sterilized glass jars or plastic containers. The jars are immediately sealed with tamper-proof lids to maintain freshness and prevent contamination. After sealing, the jars are passed through pasteurization tunnels, where they are briefly heated to destroy any remaining microorganisms. Finally, the jars are labeled, inspected, and packed into cartons using robotic packaging systems. The entire process is highly automated, ensuring efficiency and consistent quality, from the arrival of fresh strawberries to the delivery of jars to store shelves. This seamless blend of traditional cooking techniques and advanced technology ensures that every jar of strawberry jam is rich in flavor, perfectly textured, and safe for consumers to enjoy.